dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello everyone! Thanks for joining and welcome back to another day of WeAreDevelopers Live. I am Sehic and I will be your host this afternoon. Today we are going to talk about iOS development. We have 4 exciting sessions in front of us. We will talk about ARKit, Vision, Swift UI and Serverless with Swift. We have 4 great speakers with a proven track record in iOS and mobile development, so I hope that you will take something away for yourself as well. Remember, if you are watching us on WeAreDevelopers.com/live, then you will also be able to join the discussion. Just use the Q&A tool right beside the stream. Join the conversation, ask your questions, engage with the speakers. They will be very happy to answer your questions right after their talks. 2 more things before we start. First of all, very exciting news. The world's flagship event for developers, the WeAreDevelopers World Congress, is coming back to you this year. It will take place online from June 28th to July 1st. Together with thousands of like-minded developers from all around the world, you will enjoy 4 full days with world-class speakers, with networking opportunities, matchmaking, and much more. There will be more than 100 sessions about software development, DevOps, UI, UX, AI, blockchain, and many other topics. And it's especially an honor to announce that the WeAreDevelopers World Congress will be opened with a keynote by none other than Sir Tim Berners-Lee, the creator of the World Wide Web and the creator of HTML. Also Jeff Atwood, co-founder of Stack Overflow, John Romero, a legend in game design and development, Adam Bean, Brenda Romero, Rowdy Rabu, Sun Yusuf, they are all joining the WeAreDevelopers World Congress together with 100 more speakers. So you definitely don't want to miss this. Get your early bird tickets on WeAreDevelopers.com/events/world-congress and join this amazing event. Also, please don't forget to use a special discount code. You can see it in the stream. And yeah, don't miss this event. You're gonna love it. So now, last thing before we start with our iOS sessions, I want to drive your attention to our code of conduct. In short, it means we have to be nice to each other and treat everyone with respect. There is a small video that you will see explaining the details of the code of conduct, and in the meanwhile I'm going to get our first speaker on stage. Okay, I am back here with Nermin. Nermin, it's really a pleasure to have you joining us today with a session. How are you?
Hi, pleasure to be here. I'm great, and a big welcome, welcome and hi to the entire community watching us through WeAreDevelopers platform and all other content delivery platforms where this feed is being distributed.
Perfect. Thanks for the nice introduction. Can you tell us a bit what will we learn from you today?
The idea today is to go over some basic things regarding ARKit, which is getting improvements with each new release of iOS and with new improvements of iPhone and hardware. So we're basically going to look into some interesting things on how you can utilize that ARKit, and basically for anyone who's interested in developing AR applications, this is going to be a good entry point for them to understand the basic concept of AR and how they can learn and progress furthermore into developing some cool and unusual applications.
Okay, thank you, Nermin. We're looking forward to your talk, so the stage is yours.
Hello, everyone. Welcome back. As we just heard in the introduction, today we're going to talk about ARKit. We're going to have some theoretical explanations about AR in general in the first couple of minutes of this presentation, and then I prepared the two small demos showcasing how you can utilize some of the features that Apple has provided in their framework, how we can. So basically the idea is that by the end of this session or tutorial, you will have a basic knowledge on how to place a 3D model into a real world and how to interact with it, how to do some lighting, some shading, and things like that. So let me just open up the slides. I hope you can all see them. So a little bit about myself before we go into the discussion about ARKit. So I'm a full stack developer. I have been working as a developer for the last 7 or 8 years. Started working in a couple of local companies before I moved to freelancing. Some of the recent projects that I worked for were for companies such as Lufthansa, Coca-Cola, and Raiffeisen Bank. Also a couple of notable startups from mostly Berlin. My main focus in terms of development are iOS applications. The reason for that is I really like how decentralized, how ecosystem is kind of centralized. So when you actually develop a feature, you with confidence can guarantee that that feature will work on any device running that specific operating system. So it's really consistent and it's a straightforward ecosystem to be developing your applications. Another maybe interesting thing about myself, I co-founded a co-working space in my hometown in Sarajevo, which got voted among top 100 co-working spaces within its first year of doing business, which was also in the middle of Corona pandemic. Something that I'm quite proud of. And in case you ever want to get in touch with me regarding whatever, feel free to do so through GitHub, LinkedIn, Twitter, and or whatever else you use. So let's talk about ARKit. First keywords that I want to kind of stress out. So AR stands for augmented reality. During the preparation for this presentation, I kind of noticed that a lot of people get confused and kind of mess virtual reality and AR. So AR basically consists of a couple of things. First is gathering the input or an information from your device sensors, such as your camera, your accelerometer on your phone, GPS, and things like that. It evaluates them, so the framework does the evaluation of those informations and then augments the real-world images with additional information. So basically you see through your camera the real world, and then you have some additional information augmenting on top of that. Versus virtual reality, it's simply a completely new 3D world with a brand new set of information, scenes, and whatever. There has been 4 versions of ARKit so far. With each version, we had a significant amount of improvements into that framework. So each version was very interesting to work with, especially if you've been following the path of ARKit development from day one. The first version got out with iOS 11. And it was a very, I mean, it's not a simple framework, but in terms of what we have today in ARKit, the first version was quite simple. So you were basically you would be able to only detect horizontal planes if you're using AR version 1. In 1.5, you also got vertical planes, meaning you could now detect a wall and a floor as well, or any surface such as a desk or something like that. You were also able to detect 2D images. So if you point your phone towards a wall and you see a picture, you would be able to detect the object in that picture, but only if it's a 2D image. In 2.0 version, which was quite a significant improvement, which came out with iOS 12, you could also recognize 3D objects. In 3.0, we got face tracking. And the 4.0 version, which got released last year, we got a significant improvement, which is currently quite limited in terms of device capability, because it is using a LiDAR sensor, which is only built into the latest iPhone devices, 12, 12 Pro, and 12 Pro Max. Although I think 12, the basic version 12 doesn't have LiDAR sensor, and the latest iPad. And basically what ARKit 4 allows you is to draw the entire mesh of the room that you're looking through. So basically you scan the room with your phone, and you'll be able to generate the entire mesh of every 3D object into that room. Plus, it allows you to classify those objects, so you will basically be able to know if that specific object that you generated the mesh of is something where you can sit on, is it a vertical plane, a wall, some different objects. So it's basically understands the context of your room, as well as it gives you a structure of your room, which is super powerful, but again, very limited because there are only 3 devices that currently support it. So most of that technology, it's still, you can use it, but it would have a very limited reach for your audience. When it comes to general availability of ARKit, we're quite good in terms of coverage there, because ARKit requires at least an A9 chip on your iPhone, which is every phone since iPhone 6s, which is quite a good coverage, to be honest, and then all iPads from year 2017. And the important thing you need to remember is that you cannot test AR applications on a simulator. So either a very long cable for debugging, or may I suggest a Wi-Fi debugger, which works quite okay in the recent versions of Xcode. You need to be running at least a version of iOS 12, and the Xcode needs to be a version 10 or more. And you do need a solid amount of physical space in a room where you'll be testing your applications. This is due to the fact that the more you move with your phone, the more your phone scans the room, and the more it understands about where you are, the better the results will be. So if you have a very spacious, bright room, the results of whatever you're working or developing with AR are going to be much better versus if you're in a very small, dark place. But when I say a big physical space, like your living room, should probably be enough for testing of the app. So one thing you should also note about when developing AR applications is that apart from the ARKit, which is a framework itself, you do need another framework together with ARKit to be able to render whatever you want to display in the real world through your camera. There are 4 options, even though I've written 3 here, but 4 options basically. So for rendering images on top of a real world, these 3 are mostly, they're all game engines. So if you've ever done any game development in iOS, you know about SceneKit and SpriteKit and Metal. So SceneKit is used for rendering 3D objects. It's quite a popular and an easy framework to learn. SpriteKit is quite similar to SceneKit, but it only allows rendering of 2D objects. And Metal is something Apple introduced, I think, 2 years ago. So it's a hardware-accelerated 3D graphics and shaders rendering framework. And last year, Apple also introduced something called RealityKit. It's a ARKit first framework. So it was developed specifically as a helper framework for rendering things when you're working with ARKit. It's written in Swift completely. So the API is very familiar to what you would expect from a Swift type framework. But the reason why it's still not that embraced among the community is because it's very, the documentation about it is only available. I mean, best documentation is available on Apple websites. There's quite a few examples of how you can develop something, while SceneKit, SpriteKit, and Metal are already kind of mature frameworks. So it would be easier for you when you started working as a ARKit developer to take one of these frameworks instead of RealityKit, even though RealityKit is an awesome framework. On this picture on the right, I hope you can see it. You can basically see how the topology of how the view hierarchy, so to say, of an AR application looks like. So you have a session, there's a frame on top of which you add objects. And we'll see in a couple of minutes how that looks like in an actual app. Also, a few things that you need to note when you're working with ARKit, and in general, you need to have a consideration about coordinate systems. So when you're developing a normal app, an app that uses UIKit, for example, in 2D environment, UIKit applications, they have a coordinate system, so a 2D coordinate system where the origin of your application starts at the top left corner of your phone. And as you're going towards the right side of your phone, your x-axis increases, and as you're going towards the bottom of your phone, the y-axis increases. So if I'm scrolling a table view, the more I scroll to the bottom, the bigger the y. And if I have a collection view where I swipe, I don't know, an Instagram-like component for stories, swiping to the right increases my x value in a coordinate system, which is something that we're all used to. If you ever developed a game on any operating system or, well, in this case specifically iOS, you do know that the origin for coordinate system in, for example, SpriteKit or OpenGL starts at the bottom left corner of your phone. And X again increases as you go right, but Y now increases as you go up. So if you want to develop a 2D game like an Infinite Runner or something like that, then you have a character that jumps all the time. That jumping would be animated by increasing the Y-axis. So it's inverted compared to the UIKit application. Now, in ARKit, we're developing an application that is now a 3D. We have a third dimension. So we need to introduce a third axis, which is called Z-axis, and we need to introduce the origin as well. So hypothetically, let's just assume that we know where the origin in this 3D world is. It might be a bit confusing at the beginning, but just bear with me for a second. So if you have a hypothetical knowledge of this origin, you have three axes sticking from that origin. So the origin is at the location 0, 0, 0, and everything that is right of that origin is an x-axis that is increasing. Everything that is left is decreasing, which is the same as in the examples that we saw on the slide before. The y-axis increases as you go up and decreases as you go down, and z-axis extends from and towards yourself and is increasing as you goes towards you and decreases as you go away, as it goes away from you. So that's the coordinate system, but where is this origin of this coordinating system? Well, in ARKit, the origin is set at the precise location of a device when the AR session starts. So when you start an AR session, well, first of all, when you start an application, you need to start an AR session if you want to develop an ARKit application. And starting that session does a couple of things. It calibrates your phone, initializes all the sensors, and basically the device gets an understanding of where you are. And once that session is initialized, your origin is set at that specific location where you are. So if I'm here at my chair at the specific latitude and longitude or whatever, and I start my AR application, my origin is going to be at this place. But if you start the same application at where you're sitting, your origin is going to be at your location. And everything from that origin is then taken into account when you develop things, add objects into a 3D world and things like that. So now let's talk about alignments. So we have three options on how to define an alignment of ARKit session. So basically, you don't necessarily always need to have a specific alignment where the y-axis is increasing as you go up. But it is the most logical alignment, and that alignment is called gravity, and you're going to be using gravity in like 99% of cases, where the alignment works in a way that we've just described. So z-axis towards and away from you, x left and right, and y is increasing as you jump, or if you duck, the y is decreasing the same way as you would expect from a gravity point of view or description or whatever. There's also gravity and heading, which takes into account the compass of the device, and you can also use camera instead of gravity, which becomes very confusing, and it's not very suitable for most applications. If you want to read more about this, I've added a link to Apple website documentation where you can read about why they introduce different types of alignment. But just for now, let's keep it simple. We'll just assume that everything that will be working is based on gravity, which is the simplest way. So now you know that if you want to develop an ARKit application, you need to start a session. Your phone gets calibrated, we know where the origin is, and now if you want to add some objects into the scene, how do you do it? Well, All 3D objects should be part of a scene that are added to the scene kit graph in case you're using a scene kit as a framework for image rendering options, but it's a similar pattern if you're using some other framework as well. So scene kit has a tree-like structure of nodes where you're keeping the reference for all your added objects, where each 3D object can either be the child of a root or the child of a child. Your root controller, your root node is your camera, and everything that you add to that scene can either be the child of that root or a child of a child. So if you're thinking, well, why do I need to have a child of a child? Why can't everything just be a child of a root? Let me give you maybe a good example of how I understood a specific reason why you might add one or the other, but it all depends on your application logic. So if you decide you want to add a sphere to your object, which represents, for example, Earth, and you add an animation to that Earth that is just spinning like every, I don't know, 20 frames or something. And you add that object as a child to the root of our scene, which is our camera. And now you want to add, and so you run the app, you see you point your phone somewhere, you see Earth like shape spinning somewhere, which is perfectly fine. So now you decide, okay, I want to add a satellite or a moon or sun or whatever, a plane that is spinning together with the Earth. If you add that object as a child of a root as well, you would need to do you would need to do animations again. So you would need to write code 2 times. So you need to animate the Earth, and you need to animate that object that you want to have it spinning around the Earth. But if you add that object as a child of an Earth node instead of the root node, that object would get animated together with the Earth object itself. So you would only need to write a code 1 time because everything that you apply to that child applies to the children of those nodes as well. But again, it all very depends on how you structure your app and what the logic behind your app is. So now that you know how to add a 3D object, so there are 2 basically ways you can add a 3D object. You can hard code the coordinates of a 3D object into your application, and when you start the session, it basically gets there. Or you can do what we're going to do today. You're going to have an interactive app where you basically click on a specific place in a 3D world, and that place gets recorded by your phone. You get a coordinate vector for that specific touch, and then you place a 3D object there. And how would you do that? Well, if you asked me that a year ago, I would say hit tests, which was a very complex method of trial and error to try and figure out where a specific point is in your 3D world. But recently, Apple changed the way they're working with this, so they introduced raycasting, which is a very simple way. It basically, so to say, casts rays to measure the distance to the nearest surface of a plane. And that plane is something an ARKit detects by itself, which is something you're also going to see in the demo application. So we send out rays from our camera to that hypothetical plane, and then we detect the surface. And once the surface gets detected, the ray bounces back, at which point we figure out what point that is, and based on that, we get a callback in our application saying, hey, the ray bounced back at specific point, which has these coordinates, and that's where we add our object. Okay, so those are some basic information that you need to know about ARKit. I just want to share my phone now. Let's see if this works. Yes, it works fine. So I want to show you a Hello World application. I do need to get up. So basically, a Hello World application is a simple application that I wrote, which basically does a couple of things. As you can see on my phone, I have this weird sphere here. So this is a 3D object that I added inside my code. And I also enable a couple of debugging options in ARKit. So basically, I can see the frames per second data. If you notice these strange orange dots that appear and disappear all the time, those things are called feature points. And it's basically an ARKit constantly analyzing the room and trying to figure out where stuff are. So as you can see, there are quite a lot of feature points around this chair. So these 3 axes that you see here, that's the origin of my ARKit session. Basically, that's the place where I had my phone when the session was completely initialized. And then I also added the sphere as a 3D object at the origin, so at the coordinates is 0.000. And now I can just walk around this sphere it's going to stay there because that's the location of that sphere in reference to my origin. And if I just go up or down, it just stays there. And if I go away and go back again, it's going to be there. So let's see the code and how we can basically build this. So go back to my share screen and then open up Xcode. Maybe just a nod from somebody, either from the audience or somebody from the studio, if the code is visible enough, or should I do something?
It's fine, thanks.
Okay. So the way you're starting with ARKit, you basically, if you want to start a new project, you go to File, New Project, and you have this nice little hotkey here, so augmented reality app, you say next, and then you basically choose whichever rendering option you want to use. You give your name, product a name, you use Swift, and unfortunately only storyboards are available right now when it comes to UI. I already did that, and what you get basically, you get a storyboard with just one view, which is the view controller, and has a scene view, which is basically just pinned to all four corners of the room. One thing you'll notice that is new compared to a traditional app is this art asset folder here. This is basically where you would put your 3D objects or models or whatever you want to import into a scene. You're using .scn extension. There are also other options. You can basically import a .dia model and then convert it to SCN. But these are some things a person who is working with you as a modeler should know. So if you have a Blender app or Maya or something, you can just export this together with the textures. I did notice that this editor is a bit buggy. So if you like mess around with it a bit more, then Xcode can crash. So let's just not touch that too much. So this is a view controller. So I have this delegate here, which gives me access to a couple of methods. I do have an outlet for a scene that I've just shown in my view controller. I basically set the delegate. I want to see the statistics. So the frames per second feature that you saw at the bottom of the of my phone. If I just set this to false, that will disappear. And also some debug options. So the world origin. So the 3 coordinates that that you saw at when I started the app. That's basically this. And feature points. It's a very good debug habit to have these feature points enabled, so you can basically see what is happening in terms of AR. And then if you want to have your models a bit more realistic, you auto-enable the lightning. So ARKit also takes the lightning into account when it's rendering your 3D models. And then I have this custom function here. Oh, sorry. So this piece of code here gets generated by Xcode automatically. So you have a default configuration, and then you just basically run your configuration through this scene, and then you'll see in the next slide there's quite a lot of things you can configure in terms of AR. And then on view will disappear, we just pause the session if you leave it running in the background. So if you have a screen where you present something over SceneKit, like settings or something, it's always a good practice just to pause the session so your battery stays alive for longer than an hour. So what happens at this draw sphere at origin function that I've written? Let's go over here. So you basically generate a node. Now, this is, by the way, SpriteKit code here. It doesn't have to do anything with SceneKit. So you basically generate a node and a sphere with a specific size. You give that sphere a material, or actually in this specific case, just a simple color, and you add it to a diffuse object, meaning that diffuse, when you assign a color or a texture to a diffuse object, it means it's going to stay the same regardless of the lighting conditions. So even if you put it in a dark corner or in a super bright room like I'm in right now, it's going to have the same effect. But if you want to keep it a bit more realistic, then you also add a specular color as well. So for example, in our case, I added a specular white color. And when I approach the sphere from a more light part of the scene, then it's going to go from yellow towards whitish. So you have this kind of realistic idea of and behavior of 3D objects in your world. And then basically I said I want to add a sphere to a position of 0, 0, 0, which is our origin. So wherever you are in a 3D world, in your physical world, when you start a session, wherever your phone was at that specific time, that point is going to be your 0, 0, 0 when you start developing the application. And then I added the scene as a root node. I added the node, the sphere, as a child of our root node. And then basically, if I just copy this and add another one, I can add it as a child of a sphere, or I can, again, add it as a child of a root node. And that's how you develop a simple ARKit application. As you can see, quite a lot of code happens behind the scenes. So you can just basically define some simple things in the configuration and you're ready to go. So let's now see a bit more complex example, the one that I've developed. It's basically a clone of an application called IKEA Place. It was one of the first applications. Yeah, maybe I can just show my face for a minute. IKEA Place was one of the first applications that was developed using an ARKit technology and was released in production. It was one of the best examples of how an ARKit works. So IKEA Place basically allows you to take the entire catalog of IKEA, or most of the catalog, and then you can basically just browse through the catalog, and whatever you find, some piece of furniture that you like, a lamp or a chair or whatever, you just drag that piece of furniture into your home, and you can basically see how that specific piece of furniture would look like in your living room, if you want to see if a picture aligns nicely with your couch or whatever. And they built it using ARKit, and it's now one of the best examples of how ARKit is functioning. And I developed a small portion of it, so we're just going to be placing stuff on the horizontal planes, but you'll get a basic understanding of how it works. So let me share my phone again. So it's a second application now. All right. So I have this app. It's called IKEA Place Demo, and what you can see here basically. This is a list of predefined items that I hard-coded into the app, so basically it's not pulling it from anywhere from an API. And we have a chair, there's candle, cup, lamp, and a vase. And you can basically tap on it, and it says, okay, it's set as an active piece of furniture. Whenever you tap it, it works in the same way, so I say okay. And if you go to Furniture Preview, just give it a couple of seconds for the app to scan the room. So as you can see here, it's drawing a grid wherever it detects a horizontal plane. So whenever it sees like a flat surface where you can put stuff on, it says click to place your furniture here. And if I just move away and go somewhere here, as you can see, it's following me. So it's constantly scanning and detecting things in my room. So oops, almost dropped it there. So this is as far as I can go before my cable kind of kicks out. And then we can basically add a chair here. Let's see if that's going to work. So here's a chair that I've added by tapping on this piece of horizontal plane that ARKit detected for me. And if I just kind of walk around this, and as you can see, it's perfectly standing here wherever I point. And if I, for example, go here, and let's pick something else. Let's pick a cup, which is a bit smaller, a bit more challenging. See if we can detect. Yes. So here's a cup. It's a coffee that I forgot to make before this presentation started, and now it's too late. But it's standing nicely next to my laptop, and then I can also walk around with it. And it's blending quite nicely, as you can see. And then I can add some more stuff if I like, for example, this lamp. Let's add a lamp here. So here's also a lamp. Here's the cup, and if I go away here, the chair is still sitting there. And so this is a basic example of what IKEA Place allows you to do. They also have a feature for vertical planes. So if I, for example, point to a wall now, it would detect a wall, and I would be able to hang a picture on that wall as well. So now just give me a second to get back at my desk, and then we'll see a code on how this looks like. So I just pick my code. Let's choose IKEA Place Demo. And again, this is a new project developed as an augmented reality application and using SceneKit as a rendering option. So there are a few things going on here. First of all, if you go to resources, I created the specific model folder for my things. These are all downloaded from Apple website, so you can basically download them. I recommend downloading models from Apple website because you know for sure they're built properly. I tried to experiment with some other free 3D models, but then, for example, you get a chair that's smaller than this candle, depending on how scaled they are, if it's proper or not. The texture doesn't work and things like that. So safest way when you're testing, just download whatever it's on their website because you know it's been tested before. So they're all here, and the pictures that you see, I just basically took a couple of screenshots and then added them as assets here, so nothing too fancy. I created a custom UI table view cell, which has an image, a label, and some stock, just to fill some space so it doesn't look that poor when it's showing you guys on the screen. I do have this furniture service here, which returns all my pieces of furniture, and then I created this simple furniture model. It basically has an ID, which is just incrementing. It has an image, which points to this assets folder, a chair, a name, which shows up in the list, a model reference, that's the name of this model here. There's a texture and a diffuse texture. So basically, one texture gives you just the colors and things like that, and then the diffuse texture gives you this kind of rough design. For example, if there is an uneven edge, it shows you an uneven edge and things like that. And just an arbitrary number for stock. So nothing too complicated there. The way I implemented saving pieces of furniture that get transferred to the SceneKit page or view, I just basically save it to local storage. I could have done it maybe a bit differently. I could have implemented in a way that you pass from table view to the SceneKit view, or either add a drop-down in the SceneKit view itself, but it's just a matter of simplicity for this demo. So you basically, on a tab in did select index table view delegate, I just save the ID and then I retrieve it in SceneKit view. That's about it when it comes to this like boring stuff. Let's go to the fun stuff. Okay, we'll just go through the furniture view controller as well. So there's a table view, the service. I have an empty array of furnitures here. I just basically loop through everything. I show an alert when you tap it, so there's a little bit of UI going on there. The height of the cell, the count of the furniture array, and then I just render that cell. So this should be quite a straightforward stuff if you've ever done iOS development. Basic table view, custom cell, and that's it. UI alert component from Apple. So now we go to Scene View Controller. Scene View Controller is the controller where we render things. So it's where our ARKit Scene View has an outlet connection to as well. So let's go line by line, see what's going on there. So basically you import the SceneKit and ARKit here. So you initialize a couple of things. The first thing you do initialize is the scene view. So this is the thing that we saw in the previous demo as well. So we want to see the statistics. We want to take lighting into account. We would prefer 60 frames if it's possible. So if you run this on a iPhone 6s and you add like a couple of models, you're probably not going to get 60 frames per second because it's quite an old phone. And we do want to see feature points. So basically we know what's going on. Second thing is we want to initialize the AR session. So there's quite a lot of things going on here. First, we check if your device supports AR configuration, or basically if it supports AR. If you run this on a simulator, this will stop here. If you run this on an iPhone 5C or whatever, those weird iPhones that came out at one point by Apple, it's not going to work. If you run it on an iPhone 6, it's not going to work. So you just basically prevent an app from crashing or having user having a bad experience. So we want to have the alignment as a gravity. We only want to detect horizontal planes, so only flat surfaces where we can put stuff on. We also want to take into account the lighting, and we want to have the environment texturing to automatic. So basically, our 3D model gets their textures and rendered properly. So, and then we run this configuration. And this is basically the only setup that we have currently. In view will appear, we just pull the active furniture from the local storage and then save it, and also add this text to a label that I've just added here, which you can see. 1 second. So there's just a label here which says which active piece of furniture is at the moment. There is a gesture recognizer here. So we need to detect a tap on a scene where you tapped in relevance to the plane that we generated by using AR, which is thing that is happening here. So you basically, you get a location in scene view where you tapped, and then you raycast you cast array, you do a raycasting process to that estimated plane, and you only restrict it to horizontal plane. So you basically, you don't need to track if that specific plane is a vertical plane, so you don't lose in processing power, or your phone gets an easier job because you only tell him, okay, just focus on a flat horizontal surfaces. And you're going to get a couple of results. Usually the first result is more than enough. And here you basically get a vector with a location where you tapped it. And as you saw in a demo, it works quite okay. So I also did an extension of Scene View Controller where I have this AR Scene View Delegate. So this is the thing that was part of View Controller up here in the first demo. So I just kind of separated the logic to have a bit more cleaner code. So this delegate method here, it's basically going to give you all sorts of information about your session before it starts. If your ARKit is not available, if, for example, you're moving device too quickly. So if you just try and run with your device and ARKit doesn't have enough time to process your environment, you're going to get a notification here. If I, for example, take my phone, scan the room, and then just put it on a desk, so the camera is only seeing a black surface, you're going to get an information that ARKit doesn't have enough information about the environment you're pointing to, so there's something wrong with it. And if you get an unknown, well, then you're screwed. So this function here, this is a delegate method from ARKit as well, which gets called every time a plane is detected by an ARKit. So you can basically see in the demo, the first thing you see are feature points concentrating in a specific point, and then a millisecond after that, where those feature points were concentrated, we have a plane, so that white grid that was displayed in the demo. And that's basically the job of this function here. Every time an ARKit detects a specific chunk of a horizontal plane, it calls this function, and then I want to see, okay, is that a plane anchor? One thing that I forgot to mention are the anchors. So basically, every time a ARKit detects something, it adds an anchor to it. It's basically, it remembers the location of that specific thing that it detected. And you want to see if it's a plane anchor. It can be some other anchor, depending on what kind of configuration you have in your AR. For us to make it easier in terms of development and processing power, we restrict ourselves only to plane anchors because we're only interested in horizontal planes. And if that is true, our app knows it found a plane. So we know we found a piece of floor where we can place furniture, and then we can add a grid on the floor for each detected plane. Another option, as I mentioned previously, is that ARKit is constantly working in the background and scanning your room and updating itself with new pieces of information, and it gets the more you move and the more you point your camera towards different areas of your room, ARKit gets a better understanding of what your room looks like, what kind of obstacles there are, and things like that. And every time it gets a better knowledge of that, it calls this method didUpdate node. So what we basically do is, okay, we say now we have more information about a specific plane, let's just update our UI as well. So what we do, we basically remove the grid and then initialize it again. In our specific case, it can happen that, for example, AR discovered a 1x1 piece of floor somewhere in the corner, but if I move away from it, I now get a better understanding of how big the room is, and then my horizontal plane or my grid is not going to be 1x1, but it's going to be 2x2 meters. So I get a call from a function didUpdate node, so I say, okay, now I know that there's more space here where I can place stuff. because AR got a better understanding of where I am currently. Moving on. So every time you move away with your phone from a specific location, that node which you figured out, you can just delete it. So if I have a grid which I draw at right corner of my room, but I move my camera to the left corner of my room, I don't need that information staying there and then wasting my memory, so I can just delete that plane. I know that it's there because there's an anchor there detected by ARKit, and once I go back to that corner, I'll just draw a plane again. And you use this function, didRemove_node, to basically clean up your scene in case you want to optimize things. So there's a custom method here for drawing a plane, and it's basically quite simple. So as we had seen sphere object in the previous example, here we have scene plane, which is just a flat kind of object. We get the width and height of that detected plane by ARKit through the anchor object, and we just generate it as a scene node here. We define its position through the center object of the anchors, so X, Y, and Z. We make sure that it's double-sided, so if we, for example, mess up the alignment or things like that, and your plane gets switched, the top and bottom texture are going to be the same, so you won't notice. And then we just basically use an image that we have in our resources here. It's just a very simple image that says click to place your furniture here. It's basically a PNG with a drawn grid on top of it. You give it a name, it's a horizontal whatever, you can just give here your name, it doesn't really matter, and then you add it as a child node to this specific node, and we're only doing this for horizontal planes. So if you want to have vertical planes as well, then you would need to here develop a custom logic for adding vertical planes. So as you can see here, I had to rotate this plane because by default it's oriented perpendicular to the horizontal plane, so I need to flip it by 90 degrees in order to have it flat on the floor. So if this was a horizontal plane, for example, if I want to have a feature where I add picture as well as a chair, then this piece of code here would need to be different, so that's why I have this if statement here. So this is also a custom function which gets called when I click a tab. When I tap a phone through my gesture recognizer here. So basically, I get the coordinates, and then I call a function called add furniture, and I pull out the 3D coordinate system vector. I generate the position of X, Y, and Z. I get the current furniture from the local storage, which is a service that I developed, and then you just basically construct a scene with a reference to the model folder here. Model reference, and then just a scene file loaded from here. So the reason why we have model reference 2 times is because I have a folder with the same name as the scene. This is actually how I got it. How I got the models from Apple website. So I didn't want to change too much. This is how you create a node from a scene, and this is basically how you apply the material. You apply your texture, and then you also apply your diffuse textures. These are some numbers you can play with, so how much of a shininess you want your object to have. So if you have a lot of metal objects, you want to have some parameters different, and you basically, it will work without this, but it will have just a very flat appearance. You wouldn't have a lot of reality going on there. You wouldn't have any shadows and things like that. Also, what we didn't add in the scene, and you can also add it, is the lighting. You can have an artificial light hanging from a ceiling, and then you would have even more realistic preview or a look of your 3D object when you add it to your scene. So we add the position of the node that we add the position of that node to be the position that we got from our raycasting feature, and then we just add it as a child node to our root node, and that's basically it. So to recap, there are a couple of things that are going on here. It's still a very straightforward code, so we only have like 200 lines of code. If you ignore the fact that there is a screen here, which is just like a simple table view, that we have these things here, which are only just to make your scene look a bit better. We do have a lot of comments. So roughly there's like 200 lines of code, which are required for you to start an ARKit app, have an interaction with it, and then place a 3D object there. So everything within 200 lines of code, which is straightforward, really, even for somebody who hasn't been working with AR before. And that's basically, I think, a good enough example of how you can start developing an ARKit. I do have another slide here, which I wanted to show, which is basically how we can improve what we could have done differently if we had more time, which I already kind of capped 6 minutes ago. So one thing which you could improve with very minimal change is you could add vertical plane detection, and then you would basically have an option to hang pictures or, I don't know, a shelf, for example, or something. It would require 2 changes. So you would need to add a change for detecting vertical planes and placing a grid, which is vertical instead of horizontal. And you would also need to take into account which 3D objects can you place as a horizontal object and which 3D objects can you place as a vertical object. In theory, you can add a chair to a wall. It doesn't make much sense. Also, you need to take in, what also could have been improved is you can take into account different horizontal plane sizes. So if you, for example, have a desk, which is, I don't know, 0.5 meter by 0.5 meter, the ARKit would detect that it's a horizontal surface, so it would allow our raycast to give us a location where we could place a 3D object. But because that 3D object is a lot smaller than, for example, our chair, it would make sense that we cannot add a chair to a small desk. Also something which can be improved. You can make objects draggable. There are apps on the App Store which allow you to basically, after you place a 3D object in a scene, you can drag those objects around. It's basically on a similar principle that we have right now, where we just add one touch to a screen and then get one position through the raycasting. This would be a continuous thing, but it would work on the same principle. As I also said, we didn't add any lighting, which we could have added some lights to make the renders more realistic. And another thing, we could have added our raycasting. We could have used our raycasting through a focus point on a device instead of our fingers. So our fingers are quite bulky. It might happen that you touch somewhere where you don't want to touch, and specifically because you're looking into a 3D world through a 2D interface. If you have a dot or a small square at the center of your phone, it might make your positioning of your 3D objects a bit more accurate. So these are some things that you can maybe play with and then take this code and then improve it a bit. I did add everything to GitHub. If you go to my GitHub profile and then go to a repository which is called WeAreDevelopers iOS ARKit demo, you can find the entire code base for the Hello World example and for the IKEA Place example as well. And there's also a presentation here. Feel free to use this code in whichever way you want. If you notice that there are some improvements, you can open an issue and then we can improve it together for other people to maybe benefit from it. Or if you can use this code in some way for your next project, it would be awesome if you can basically use some of it. And that's about it from my side. I was told there's a bit of a delay between me and people watching, so in case there are some questions, I guess I'll wait a couple of seconds to see.
Yes, thank you very much, Nermin. It was really a very cool talk with a really very cool topic. Let me just see if we have some questions. Yes, there is quite a lot of questions. So let's see, we are a bit tight on time. So let's see what we can work through here. I'll start with the first one actually. Okay, very general. What would be the steps to make a multi-user network app, for example, a real-time AR game? I think it's more about like how would you, like connect it real-time with other people?
It is possible. It's basically a very complex set of API calls, so to say. But I think there are people who actually developed a social network using ARKit. So it's basically just a matter of placing a 3D object of an actual person into your scene. So like a more interactive version of Pokemon Go, so to say. You wouldn't be able to use Syncit. It's probably it has a lot of limitations, so you would use Metal as a rendering option, and maybe some sockets to get a better response when it comes to, I don't know, walking or interacting with a person or something like that. But in general, it wouldn't be too different from what you just saw.
Okay, thanks.
Not that I've developed a 3D interactive AR app.
Yeah, I think like when you think what will be available in 2-3 years or 5 years, I think that.
I really want to say that while preparing for this presentation, I was quite impressed with what I saw, what you can build with this ARKit 4. It's really an impressive set of tools, especially because you have this powerful sensor in your phone, you have an amazing processing power, and then you have a super simple intuitive API which basically gives you all of that. And I saw a demo application of a guy who goes to his apartment with iPhone 12 Pro Max or whatever the latest one is. He scans the entire room using this LiDAR API, and he was able to generate a 3D model of his entire house just by scanning a room from his phone. And he got all of that within like 2 minutes of walking through the house, so he gets a kind of a better understanding of how things work. Because it has a depth sensor, it's just impossible. It's amazing what you can do with just one framework and one device. And in 2 years,
yeah, that's amazing.
We'll embrace a bit more. So when you ditch kind of these older devices and you have like, I don't know, iPhone 13 and 14, so the 12 becomes quite affordable, it will be amazing to see what people develop.
Yeah, looking forward to some interesting games as well. So next question, what about battery management? Does it drain a lot? Or maybe I would add to that one, what can you do to improve something about battery issues?
Regarding the battery, it does drain battery to some extent. It's especially, my brain froze. It's especially noticeable on older phones. Like if you run this on an iPhone 7, for example, iPhone 8, it's an older battery, plus it's a smaller battery. You do really notice that it's struggling quite a bit. But again, it all depends on how complex your scene is. So if you have like 20 3D objects in a scene with a lot of polygons and things like that, it's really gonna drain your battery. But that's not something that is only specific to AR. It's something that is generally a rule when it comes to 3D games and everything. So you need to optimize, I guess, the models, first of all, as much as you can, which is probably not the job of a developer, but a job of a designer or a 3D modeler or whatever the name of that position is, or a person. And when it comes to your code, you can do a couple of things. As you saw in view will disappear, pause the session. If you get a delegate call that this specific part of a scene is not visible anymore, just delete everything and then re-render it when you come back. It's basically a hack game developers have been using for years now. So you only render part of a scene which you see. So if you, for example, play, I guess, World of Warcraft, where you have a huge place to render, you only render what you see, and then if you move away from it, this part here gets deleted, so memory gets cleaned. So just hack it as much as you can, I guess.
Okay, then another question. Yeah, what about performance on older devices? I think you already touched base on that. Do you want to add something to that? Or?
As I said in the beginning, the reason why I love iOS development is you get this sense of consistency. So if Apple says that something is going to work on a specific version of iOS, it doesn't really matter which phone you have, unless it's something super complex. So if you're talking about like some general usage, for example, I want to place, I don't know, a couple of pieces of furniture in my room, you're not going to notice any difference between iPhone 12 and iPhone 6s. They're going to work just fine. Some more complex things, you might notice a bit of a slower performance. For example, when you add a 3D model to a scene, it takes a second for it to kind of appear, render, and then show up properly. So on an iPhone 12, that might be a bit of a faster operation than on an iPhone 6. But you would notice it because you're developing it, but if you have a user with, I don't know, a 6-year-old phone using an ARKit, I'm sure it's going to be fine for him.
Okay, then another interesting question. What are the limiting factors in terms of distance or size of objects that you could detect?
General rule, so the limiting factors is light. So the more light you have, the better understanding ARKit has. Limiting factor in terms of vertical planes, specifically, the less texture you have, the harder for the phone to recognize that surface is. So the most difficult part when it comes to walls, for example, is if you have 4 basic white walls in your room. There's a 99% chance your ARKit application won't be able to detect it. It will be able to detect it when you're talking about generating a mesh structure with the latest LiDAR sensor, but if you're talking about a basic ARKit application, so white walls are really the enemy of ARKit. What else? I also had one more. So in terms of distance, something that is over 5 meters away is generally harder for ARKit to detect. And also, if you don't move too much, ARKit is struggling to basically understand your room. So if you basically, like if I was just sitting here and I pointed my phone towards that piece here where I added a chair, I probably wouldn't be able to detect that it's a flat surface over there. So I need to stand up, scan the room a couple of times. So you do need a lot of space as well. So that's maybe also one limiting factor.
Okay, perfect. Nermin, thank you so much also for answering the questions. We are going to our next talk as we are already a bit over time. But I again want to say really a big thank you. It was super interesting, a super interesting topic as well and well presented. So I hope to see you in the future, in the near future, maybe also at our World Congress again. Have nice greetings here from Vienna to Sarajevo and see you soon again.
Yeah, thank you for having me. And I guess to the audience, enjoy the rest of the lectures. And again, if you ever feel a need to get in touch or discuss something, just feel free to drop me a message.
Thanks, bye. Okay, so we are making a break, just 2 or 3 minutes to get our next speaker on stage, and then we are coming back to you with our next session. Okay, welcome back. I'm here with Milan, and it's a pleasure to have Milan again at our live sessions because actually, right, I think around a year ago we had one of our first live sessions with Milan, and now it's a pleasure to have you again here. So, Milan, how are you doing, and where are you joining us from today?
Oh, thank you very much. It's let me tell you in short, it's very good. So weather could be a little bit better, but if that's the only issue, it is okay. So it is pretty good, and I'm really happy to be here again with you and with our attendees.
Perfect. Can you give us a short introduction of what we will learn from you today?
We'll talk about very specific usage of machine learning, actually computer vision by Apple, and how we can use this computer vision libraries in our apps. It is techie presentation, really techie, deep techie, and it actually demonstrates how a developer can include this really interesting feature in apps, especially when we are discussing about understanding of our mobile devices, of our hand. Okay, so the hand is the main. I'm just trying to put my hand in the middle, and we will show how our iPhone can understand positions of our hand. So this is the reason why this presentation has the name and the pose of hand pose with iOS.
Okay, perfect. That sounds very interesting. Milan, the stage is yours.
Thank you very much. Okay, thank you very much. I'm happy to be here now, and as usually, I will show you how to work with iOS and iOS programming live. So the major part of my presentation will be from Xcode, which is, as you probably know, the most important development tool when we talk about iOS development. So, but first, let me tell you a few introductory words, and so who I am, what I do. Actually, I work for Apple Certified Training Provider, and my position is Apple Certified Trainer for Swift, and I do this since the very beginning of the Swift life. And this is actually what I do on an everyday basis, and I cooperate with WeAreDevelopers for a couple of years. Had sessions in Warsaw, Vienna, Berlin, and so on. And I hope this is going to be like this in future as well. And I hope that after Corona time we will have plenty of opportunities to meet in life. So, and let me talk about vision, about vision framework. This is uh, this is actually the piece of code, piece of working code used to created to enable developers to make time to market much shorter. So Vision can do a lot of things out of the box, and it includes machine learning related to computer vision. It has been developed by Apple. It includes detecting and classifying human activities in real time, which is actually the topic we will cover today. It enables locating and demarcating different types of objects like rectangles, faces, barcodes, text images, and so on. Vision enables classifying images. Actually, I had lectures 2 years ago in Vienna and Berlin related to classifying images, and under the hood, the classifying images uses vision. Of course, you can use vision for image similarities, for detecting and tracking faces, and so on and so on. In general, I'm going to talk about the classes which do the real work. In general, Vision Framework is doing by requests. It's quite simple idea behind that. So there is an image, and this image will be provided to request handler, which will respond somehow depending on the planned application and plan, depending on the basic idea. In our demonstration a little bit later, you are going to see how looks like the request handler for hand pose. If we take a look to our hand, of course, 5 fingers, and of course there is wrist, palm. What actually vision can recognize? What landmarks can recognize vision here? Actually, whenever vision sees the hand, it looks for 4 landmarks for each finger, 4 landmarks for thumb in addition, and 1 landmark for wrist. It means total recognition of 21 landmarks in every image containing the hand. So let's say about this landmarks, how are those landmarks named? So every finger has a tip, so this is the top of the finger, interphalangeal joint. Of course, before this I wouldn't understand the word interphalangeal. It is not too important to remember this word and to say this properly, but let's use abbreviation IP. This is this point, on the finger. I will try to show in my camera. This is actually IP. Metacarpophalangeal joint is on this position, and finally metacarpal, it is here. And as you can see on this slide, there is a point which is actually wrist. So vision can recognize all those points when they are visible, and additionally we can do whatever we want, maybe to understand the positions and so on. In the demonstration you're going to see in minutes, which is standard Apple's demonstration, you will going to see how we can use pinch, how we can recognize the pinch on our hand. Okay. It's not working always perfect. There are some issues sometimes, but it is not regarding the technology. It is regarding the real life. If camera can't see your hand fully, simply it's not possible to understand everything, because camera is, so to say, two-dimensional device, and it is important to enable camera to see your hand properly. So some potential issues can be if the hand is near the edges of the screen, if we are putting our part. So if you are looking to the hand like this, you simply can't see it in a simple way when hand is oriented so or So having gloves on the hand actually can produce some errors, and additionally, sometimes if feet are presented on the image, it can cause the issue as well. But it is not so big problem. I'm sure you're going to see how does it work very quickly, and I hope you're going to be satisfied with that. I will now jump from my presentation to code. And just a second. So this code you see in Xcode, this is the code you can take from Apple's website. If you jump to this part, developer.apple.com, and make a search with something like hand pose, you will get link to the page. Just a second, maybe some. Oh yes, here it is. Here is the original demonstration from the WWC 2020, and so let's say can post request something like this, and you are going to be able to take a look to this. You will be able to download this code I'm showing you now. Actually, I cannot find it right now, but I will put it later as a link. So let me go on. I will come back to find this this link. So in this code, practically we have three main parts. One part is related to camera view, which is actually the view, the exact view we see through our iPhone. Another one is the view controller, which is container for this view and the container for important code, which handles everything and which is actually controller as its name says. So it connects the camera part with handler part. And the third main part is this processor, which actually is doing processing of so-called hand gestures. It analyzes and where the points are and doing additional required functionalities. In addition, I will try to show you what I have in my hand. This is my iPhone. I hope you see that. Okay. Oh, yes, that's my iPhone. I'm sure you trust me. And this iPhone has been connected by the cable. And I will start QuickTime to be able to show you here the screen of my iPhone. So this is QuickTime Player. My iPhone 12 will be now unlocked. And so I hope you see my, okay, so here it is. I hope you see my screen pretty well. And this is as I said, the screen of my iPhone. Now I will start the app as is. And after I will show you important parts and functions. And QuickTime. So you see me from different perspective. Why? Now you are going to see my hand. I'm sure you see these two orange points. These orange points follow my thumb and my index finger. Actually, the tips of those of index finger and thumb. But if I make them close, Okay, now I can actually produce this gesture. I'm now moving my hand fast, and it disables the recognition because it has been set so in the code. But let me show you again. If I move my hand slowly, I can put some content that has been drawing following my fingers. Okay, if I double tap, I clear the screen. Maybe I can draw some rows or maybe some heart for you. Okay, I'm not drawing very good, it is obvious. And now I would like to stop this app and to jump into the code to show you what parts of the code are responsible for what functionalities. Camera view is, as its name says, it is the view. It is the code which will be responsible to show those points. Actually, we have 2 points in this example, and let me remind you that 21 points can be generally recognized. How? You will see in minutes. How exactly? You will see in minutes. Here is actually the piece of code which draws this points, orange points. Their radius is 5, and angle is 2.5 means full circle, and it overlays over the content of camera. Okay, the most important part is camera view controller. I will just show you what important properties has been listed here. Here is the camera view, which is actually the camera view you already saw. Then there is a video data output queue, which is queue feeding the app with content from camera, video session, and very important visual part of vision framework named Visual Detect Human Hand Pose Request. All those classes and functions from visions start with VN in the beginning. So VN detect human hand pose request is going to actually do that, to analyze this hand pose request, and the piece of code where this has been created is actually here. So here is the hand gesture processor. If we jump back to camera view controller, you will see the overlay for images. This draw pad is responsible for drawing on the screen, and the class UI Bezier path has been used. Evidence buffer actually contains the pairs of gesture. Why pairs? Because I use 2 fingers. So I use thumb and index finger, and connection between thumb and index finger to handle. And of course, some helpers like last draw point, observation timestamp, and similar things. And finally, hand gesture processor, which is, as I mentioned, related to this human hand pose request, which is doing the job related to recognizing fingers and getting a response where our fingers in the image are. Okay, and so practically the most important part is here in this extension, which is actually extension of camera view controller. In that area, we will actually handle thumb tip and index tip. So this means conversion from vision perspective where our tips are, to conversion to core graphics, because actually we recognize where fingers are, where tips of the fingers are, and use this to draw our Bezier paths, our lines. Okay, so this is processing, but now I'm coming to the most important part. I'm sure, just a digression, a short digression. I'm sure it is not easy here to understand everything in this 30 minutes or 20 minutes, but this code is practically very simple if you dive in, because as I mentioned, only 3 important parts are here, and the most important part is this here in this extension of camera view controller. And now here is the VN image request handler. This is the place where Vision actually handles this buffer, okay, oriented to up, and is handling what is needed. And now here is the piece of code where we actually receive the observation from this vision, from hand pose part of vision, and this observation will contain the fingers that are presented here. And now I get the thumb point reference and index finger reference. So it's quite easy to understand what does it mean. So I actually have the enum value, which contains all fingers. So what fingers do we have? All fingers, index fingers, little finger, middle, ring, and thumb. Okay, it's quite easy to understand. And this is the way how I recognize, do I have contact with thumb and with index finger. In addition, it's not only about fingers only, it is about joints on the finger. It is about landmarks on the specific finger. So here I can get thumb tip and, let's say, index point tip. So this is the reason why my orange points are on the tops of my fingers. Let me just show you if I change, if I do not use index. So let me say not index tip, maybe index MCP, just to show you how does it looks like if I start app again on the screen. Okay. Now I just need to unlock the screen, need to start the app, and need to show you in quick time player. Okay. Okay. So please take a look where the points are now. There is the tip of the thumb, okay, and there is MCP, which I actually cannot repeat again unless I take a look to the to the presentation. So if my fingers are visible fully, it follows very good. But if I do something like this, okay, I mentioned you that I will probably have some issues. But even in these cases, please take a look to the point. Systems can handle this pretty well. Actually, I think that he knows where the root of my index finger is, even if it's not fully visible. Okay. Sorry. Let me stop this presentation. Okay, and a few more words. What actually I do after I get my let me put this back. What can I do? I in this presentation, actually I created not me. Actually, Apple created processor. I just make some minor changes. Actually, here are 5 possible states of my fingers presented. It is pinched and apart. What means pinched? It means this. What means apart? It means when my fingers are apart. Okay, so there is a value which defines what does it really mean pinched and what does it mean really apart. Because it is possible to have some very specific position, there are possible pinch and possible apart included, just to cover all possible situations. So here is this max distance, which is actually 40 points. So it is something like this. It is maximum distance, which will be considered as a pinch. To make this app working, these properties like pinch evidence counter or apart evidence counter have been included. And here is actually the function that takes care about increasing or decreasing number of pinches and aparts. So it is this extension is some helper which can be used to make things look better. And practically this would be this short presentation. I will jump a little bit back to my key point presentation to mention you that hand pose has been related with human body pose as well. Human body pose works practically in the same manner. Human pose analyzes the position of the human body visible in the camera and finding important landmarks. These important landmarks are ears, eyes, shoulders, important big joints, and similar. And practically you can use the same app, but to avoid using hand pose and to put human body pose, and you will be able to analyze the position of the body which is presented. It can work for one body or many bodies. It can recognize a lot of points, more than this presented here. And as I mentioned, you can use this hand pose demo to create your own human body pose demo, if you like. Okay, so I had idea to finish everything in 35 minutes, and now it is exactly like that. I promised that I'm going to find this demo for hand pose. Now I'm going to do this, and so developer Apple, sorry, Apple.com, and hand pose demo. Oh yes, here it is. Here is the link. I will now put this link in this sessions chat. So you can jump quickly to this. So actually, this was the short presentation, just to maybe to suggest someone to try to work with this. I tried, it works really good. Probably there is a lot of a lot of ways how we can use this in real applications. This is the way how mobile devices can communicate with people in a much better way. Probably you can write apps that will analyze and understand, so to say, hand language, or even real hand languages for different purposes. Okay. If we include human body pose, I'm sure there is going to be a lot of ideas how it can be used. Apple suggests some examples, like that if you can use this way to analyze the images, maybe you can analyze if one image is very interesting or or can be very popular or something like that. So actually this was this was my plan. If you have any questions, I am available. Now I'm going to stop my share and please go with questions. Thank you very much.
Okay. Thank you, Milan. That's quite interesting. If you basically put together the stuff from Nermin's talk and your talk, then we would have something like Minority Report. So maybe you should kind of join forces.
Yes, it's always interesting to join things.
Yeah. So yeah, let's see if we have some questions. Maybe a concrete one. What are some practical and popular examples in apps that are available today? I think it's the question relates to really like something that we could already try out from download something from the store. So do you have some tips?
Well, actually, this is not this is so to say brand new. Thing. It has been published less than a year ago, and there is not too much. There are not apps now, but I am aware that some people are working on understanding the hand language for disabled people. This could be very interesting, and then some specific counts. Then let's say putting marks on images, identifying parts of video recordings which are interesting in some way, having hands, containing hands, and similar things. I'm sure there is going to be a lot of addition, but so I'm developer. Okay. So okay. I hope I gave some answer. Yeah.
Yeah, I think there will be like a lot of popular use cases also when I think about maybe collaboration with others and so on. Let's see what time brings. Another question, also the last one that I have currently here is it possible to use it offline?
Yes, definitely. Yes, yeah. The answer is absolutely. And I would like to tell you that you saw demonstration on my iPhone, and my iPhone has been on airplane mode because I simply didn't want that anyone give me a call, and I was not on the net. This works on device only, and it is probably important to remind that Apple's approach is to do everything on device without potential security issues. Everything is going to happen on the device.
Okay, that's very nice. So Milan, there is no more questions, but I would say a big thank you for joining us again, and I hope to see you in the near future again. Also, maybe you're joining our World Congress. So is there anything you want to still say to the audience?
I would like to first of all say thank you for your time, for your interest. I can suggest, recommend, whatever, to try this code. That was my approach. Please just download this code, try to create that, try to change something, and it is possible that your idea can go to the stars with this. So the most important thing is that the time to market is now much shorter than it was years ago, and practically anyone with small development experience can create big things.
Okay, perfectly, Milan. Thank you so much. See you in the future soon, and we are going to have a short break, around 15 to 20 minutes, and at sharp 3 p.m. we are coming back with our next talk about Swift UI in production, with also one of my favorite speakers, Peter Steinberger. So make sure to tune in, and see you in a couple of minutes again.
Dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to 130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now. Dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to 130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Okay, welcome back everyone to our third session of the day. I am here with Peter. Peter, thanks for joining. How are you?
I'm doing well, thank you.
Great. Where are you joining us from?
I'm in Austria, Vienna.
Okay.
So pretty nice day.
In home office?
Yes, of course.
Okay, good. And tell us briefly what is your talk going to be about?
My talk is about Swift UI in production. So everybody knows Swift UI is like this hot new thing, but it's also like dangerous. And most people stay away from it currently because it has problems. And we ship something in production now. And I'm talking about the road, how we got there, a few of the dirty hacks we had to apply, hopefully inspiring some of you to also try it.
Okay, we are looking forward to your talk. So Peter, the stage is yours.
All right, everyone. So let's talk about Swift UI in production. Swift UI, as I just said, currently, and I'm talking actually May 2021, is in this really uncomfortable position of showing a radically different way of building UI, but also being so new that it's risky to use. So you both hear people praising it and people cursing it. If I'm very honest, I did both. And there's really great small examples from a lot of folks and also from Apple that show you how amazing it is. And on the other hand, you see random attributed graph errors or crashes and all the things that are missing from Swift UI. So we wanted to know. So we tried it and recently shipped a major new feature completely built, or almost completely built in Swift UI. And also we are still supporting iOS 12. So here's how we did it, and here is what we learned. And a little stepping back before, as you know, my name is Peter. I live in Vienna. I started working with iOS way back when we still had View Did Unload. Unfortunately, I don't see the faces here, but I would love to see hands who still had to suffer through the time where you had to think about view unloading. And yeah, I love learning new things and digging into technologies, especially if they're still a little bit rough. So currently, my Twitter is mostly focused about Swift UI specifically. Usually, it's always iOS topics. You can follow me at Stipete and experience the highs and lows with me. And I also founded a company called PSPDFKit in 2011. So what we do at the company level is we're a small remote company. I always say we were remote before it was cool. And we focus on solutions to show, annotate, and also to sign documents, mostly PDF, but we also support Office and image files. So you can display them, annotate them, fill forms, digitally sign them, merge, flatten, you name it. We are available on all platforms. And the interesting part is that unlike some other solutions, we have a custom built UI for each platform specifically. This is harder, but we did chose this path so the product feels like a natural extension of the OS, something Google would build or something Apple would build, and not a cross-platform compromise. So I've been actually very critical towards Swift UI in the beginning, and I would say for about a year. But I also heard a lot of reports from people that said how amazing Swift UI is, so I wanted to give it a go. There's quite a famous blog post called The State of Swift UI, where I take apart Apple's Fruta example project. Now, Fruta is a Swift UI multi-platform app. So it's native each with AppKit and UIKit, and it's only one code base. There's no catalyst being used here. The AppKit bindings specifically are a little rough. So as you see here, as I click around, there's things that jump around, and it's actually quite easy to bring it into a state where it crashes. It's usually always in the attributed graph parser, which is the thing that diffs the view and makes Swift UI work. Now, Apple improved things a lot since the first time I looked at the video. You see that now we are at the crash. This specifically is actually like something with the toolbar bindings. Things got a lot better, but the macOS bindings are still not as good as the iOS bindings. But the good news is that you have to try quite hard now to crash an app. And I would actually argue that if you give me an app and I play with it a few minutes, I'm able to break almost every app with just like monkey clicking. But if you mostly focus on iOS, then things are a lot better. And I came from a situation where I had like very little knowledge of Swift UI. So before shipping something in our SDK that's used by many of the Fortune 500s, like Dropbox, for example, we wanted to have something that's a little bit lower risk, where we have a little bit more control. So I did pick PDF Viewer, which is a free app that we ship for iOS and macOS. And for macOS, we actually use Catalyst. And we recently dropped iOS 12 there. So it's a relative contained and straightforward target. Now, what I did here is I first rewrote the existing settings in Swift UI. As you see in the picture, the settings we had very much look like settings you do in iOS and not like settings are on the Mac. So my first step was to don't care about the UI, just make it work like the previous version and just rewrite it in SwiftUI. Once we shipped that, I went back and actually started styling it so it actually looks like a Mac signature UI, and still most of it is shared code, which is also quite easy because we use SwiftUI. After we shipped that, the next big feature we picked to try SwiftUI was a new feature for electronic signatures. Now, signatures are an important use case, and we've been supporting PDF signing for years. It's one of the most used features on our platform. But with the new flow, you can not only sign via drawing, but you can also sign via scanning a picture or just typing a signature, something that you commonly know from companies like DocuSign. Now, also because it's such an essential feature, the previous UI has been written quite a while ago. So it was still in Objective-C, it didn't use auto layout. You could definitely feel the age when you worked with it. So it was a good candidate for a rewrite. Now, what we did for OS compatibility is we plan to drop iOS 12 later this summer when we start working on iOS 15. And I think WWDC is now around 5 weeks away. So that's actually probably going to happen very soon. But until this happens, the existing drawing signature flow, which works fine, also stays in our product for the iOS 12 users. And if we detect iOS 13 or later, and also with the card license, we switch to the new flow instead. For us, SwiftUI is attractive because it greatly simplifies the flow of updating views. It's much harder to make an update-related bug, and it's easier to reason about the UI state at any given moment. And I would say it's actually much, much easier, especially for complex UI. Another reason that we as a team, we have the motto that we're only allowed to write UI in code. Now, with Xcode, you can also build UIs with Interface Builder. But if you work in a larger team and you tried to merge files that are in conflict, you know the pain. So that was one of the reasons why we said, no, this is not worth it. We write it in code. It's a little bit more work up front, but at least we don't have to deal with merge conflicts. So because we already write all our UI in code, SwiftUI is such a big step up because it's just so much fewer code and so much more expressive, which we see as a big win. Another benefit is that what Apple did right here is it can be mixed with existing code very easily. For example, our draw view, the one where you draw the signature, is highly optimized, and we have features such as natural drawing, where we change the thickness of the path as you move along to simulate how you would draw with a pencil. We support predictive touches, so especially with the Apple Pencil. We kind of know where you will already go next based on some of the data. So you really get this feeling right where, as Apple say, it's a magical experience and the line just sticks very much to where you draw. Now, there's a lot of tricky mouse in there, and this has been written in Objective-C++. And I argue, and hopefully someone challenged me at some point, that currently this cannot be done in pure SwiftUI. There's simply no API for high-frequency touches, for predictive touches. That's just not have been ported at all. So if you want to deal with a great number of points, you probably need to go down to the platform level anyhow. Now, this might be a little bit overkill for a signature, but we also reuse the same draw view for PDF pages. And imagine if you make a lot of handwritten notes, then performance is really critical. And by using SwiftUI, we can still use that very draw view and don't have to reinvent the wheel. Now, I did imagine that our SDK started in 2011. There is a lot of code. And until very recently, actually with Swift 5, we couldn't use SwiftUI. We couldn't use SwiftUI because our customers, they want to have flexibility of using different Xcode versions. And only with version 5, Apple added binary compatibility. Previously, you would have been bound to the very patched version of Xcode. So there's still a lot of Objective-C in there, and it's not realistic or useful to rewrite everything just for the sake of rewriting. But also don't worry, this will be the only slide with Objective-C on it. In this code, you see that how we invoke the feature. The SwiftUI code is encapsulated in a UI hosting controller. The presentation is handled by UIKit. And SwiftUI really is fairly contained in the signature component. If we detect iOS 12, that is the first part that we call legacy signatures, we defer to the previous signature component. This still works great, just isn't as feature rich. If we detect that we are on a modern OS and that the internal licensing works out, we move to the new signature creation view controller. And the only difference you probably see here is that in our new component, we use navigation view because we also want to fine tune the buttons in SwiftUI directly. So there's like a Boolean that indicates if the controller needs wrapping or not, but otherwise the flow is very much similar. And ultimately our customers, they never know that they're actually using SwiftUI. They still have an Objective-C API if they do so. We have some large customers that still have code bases where they don't want to move to Swift. So it was important to like have the full range offering on the API level, but also we can use like really recent technologies. Now, there is of course also a lot of challenges of SwiftUI. And in this presentation, I'll refer to SwiftUI for iOS 13 and Catalina as SwiftUI 1, and SwiftUI for iOS 14 and Big Sur as SwiftUI 2. And in a few weeks, we'll all be waiting for basically the announcement of SwiftUI 3. Now, supporting SwiftUI 1 especially has its challenges. Often when people write about this cannot be done in SwiftUI, they're both correct and wrong. The beauty of SwiftUI is that it's so easy to like freely mix components with the platform ones, with UIKit or AppKit on the Mac. So you can always add missing features yourself or work around bugs. And I'll show you a few of the workarounds we had to do to polish our electronic signature component. Also, consider that if you're adding hacks specifically for SwiftUI 1, this is a fairly safe thing to do. The OS has already shipped, and even if you apply something you would consider dirty, such as introspecting the view, it will work reliable because that version is done, that version shipped, and that version is no longer changing. So you can like really test your hack and just make sure that you don't ship those things in SwiftUI 2 and the current OS, because of course it's much more risky that Apple changes something in, let's say, iOS 14.5 that came out 2 days ago. And they will definitely change a lot in iOS 15 that will come out, at least a beta in a few weeks. And yes, because there's probably a question that comes up. We found that SwiftUI previews are not specifically well working for us. They seem to work well for a small project, but in our larger one, they frequently timed out or just showed random errors. This is an area where I really hope Apple will improve, because they are by far the fastest way to iterate. But even if you ignore those, and even if you just have to restart your app and go to the scene, you're still much faster than writing plain UIKit or AppKit. Now, let's start with the first trick we had to apply, presenting a popover on iPhone. This is something that looks simple, but really is not. Now, when our signature controller is in landscape, we don't have space for the font. So what we do is we use a popover to show the font picker. In SwiftUI, popovers are always presented as sheets in compact size class environments, which the iPhone is. Apple added something that's called adaptive presentation style. And if you use that, you can show a popover even on iPhone via returning none in this specific delegate. Now, this is how you do it in UIKit, and there's just no equivalent for that in SwiftUI. It is, of course, possible that you completely rebuild that popover experience by yourself. But, you know, there is shadow. There's like a lot of little details that you have to get right, where tapping works, where it's being dismissed, which just seems a lot of work for us using the existing UI framework logic. Now, to mix and match between the two worlds, we do need a few tricks. Presenting popovers in UIKit needs a source view to anchor. You need the coordinates And also you need a view controller to present it. We have nothing like that in SwiftUI by default, not even a UI view. However, if we embed a UIKit view in the SwiftUI hierarchy, we later can access it and both get the view and from there also the view controller. We wrote a small helper class that we called anchor button, which resolves this and passes the view that it embeds on a tab. So in the action tab, you can use the view to show the font list controller. What do we do once we have the view? Actually, our font list controller offers a convenient way called present to present itself on a view. I would say this is fairly straightforward logic, as you know from UIKit. The one thing that's special about it is that we need to get from a view to a view controller, and we're using the helper. You see sender.pspdf_closest view controller here. And what we do here is we actually use the responder chain, which next responder, to find the nearest view controller. This might feel a little bit dirty to you. However, you have to know that the responder chain is fully documented. It is documented that it includes views and view controller and also in which order. So really, this is a safe operation to do. And even Apple does this sometimes internally in UIKit. Now, in the remaining logic in view.load, we simply add the signature font list, again, a SwiftUI view, as the hosting controller. So in this case, we're using a helper to set up auto layout constraints, so it has the same size. And also because we really want to get all the details right, we pass in a delegate, a closure, sorry, so you can dismiss the container view controller programmatically. If we put all together, then we have popover presentation via UIKit, but we only use SwiftUI components for the view. Now, the beauty here is if you rotate again, or if you have enough size again, we don't need any of that, and we can just use the signature font list view in SwiftUI directly. Now, currently, this whole popover presentation logic is used just for the font controller. So we haven't made it generic yet, but it honestly would be pretty easy to make this a reusable component and use it in different parts of our code base. In our coding philosophy, we apply Yagnai. You ain't gonna need it. So we will refactor this if we have the need, and we know that we have this now, but so far there just hasn't been a need to actually make this generic, and often this is like unneeded work. Another benefit is that by using this approach, we're actually working around the bug in SwiftUI where defining more than one popover modifier doesn't work until iOS 14.5. So this is also something that you have to be aware with SwiftUI, because it is, I would say, hot cooked technology. Apple does fix a lot of things in minor versions. So you do want to test this with iOS 13.0 and also 14.0 and 14.5, because there might be fixes along the way where everything works because you test in the Monday's release of 14.5, but then the popover doesn't show up in 14.4. Now, let's get back to anchor button. It's actually by far not as tricky as you might imagine it. Internally, the struct wraps a regular button. And we also, as I mentioned, add a wrapped UI view behind the button in what Apple calls a set stack. I could probably also just use the dot background property to do the same. Yeah, there's no particular reason where one is better than the other. Now, we keep track of the UI view and pass it as a parameter to the closure that's called when the button is pressed. And that's already everything that's to it. I'm linking the gist, so you can check out the code. There's also a blog post where this is listed again, so feel free to use this code whenever you need it. Everything we share is usually licensed under MIT. Now, let's talk about the toolbar API. SwiftUI 2 introduces that .toolbar modifier, which greatly improves the toolbar, how toolbar items can be added. The new API gets a few details right, such as making the done button confirmation bold and really almost 100% matching the UI experience. On iOS 13, there's a different API called navigation bar items, leading and trailing. However, there is no simple API to actually center elements on the toolbar. And if you remember the picture that I posted before, we have this big control in the middle to toggle between signature, image, or text. This needs centering. Now, what we do here is we actually just use Swift UIX. It's a really good project that fills in gaps that are missing in Swift UI. It's free to use. In our case, we didn't pick the whole project because we are an SDK and size is quite important. So we really only picked the file that we need. If you don't have these constraints, you can just add a Swift PM package and have it all. And there we have a version that's called navigation bar items, leading, center, and trailing, which made this very easy. And you see in the code here that we actually wrote both versions because we already anticipate that in a year or in 2 years, probably more 2 years, we can drop iOS 13 and then we have cleaner code. And we don't have to rethink of, okay, how can we rewrite this and why did we use the old API back then? Now, actually, one thing I forgot, if you look at the code, you might argue that we could probably deduplicate some things. We could use a conditional view modifier. And this is also a pattern that you will see a lot in Swift UI. However, in our case, the old API on iOS 13 is not available. So we had to use this hashtag available, which doesn't directly work with postfix expressions. So the macro stuff that you have in Swift is not quite the same as the macros in iOS, in Objective-C. So currently, it's not possible to write this easier, but there is a proposal, current iteration, named SE308, which will allow you to support if in postfix member expressions. Now, this all sounds fancy, but you see on the picture that is actually quite a simple concept where you can use if within this dot stacking and don't have to think about it. This is currently something that's not working, but my guess is that in 5 weeks, when they're stopped up in the new Xcode, this will be implemented. And then you can actually further conditionalize and simplify the code. Okay, now let's talk about every Swift UI developer's worst nightmare, the attributed graph precondition failure. Now, the horrible beauty about it is that this crash usually has no symbols of your own code. So to maybe explain a little bit, like Swift UI creates a structure of your view, and then it uses the attributed graph to build UI out of that structure and also to diff the existing UI and modify it so it matches your new structure. There's a lot of gnarly and complicated code. It's a lot of C++ that Apple wrote there, and there are bugs in it. So sometimes you just find a condition where things just crash. That's unfortunate with almost any new technology. And in Apple's specific case, it's also problematic because you can't ship your own Swift UI in the app. You have to use the Swift UI version that's on the OS, on the device. So if there's a bug, you'll probably have to live with it for quite a while. There's no great concept to actually work around this. It's good to test early and test often, which the iteration cycle actually makes you want to do automatically in Swift UI. I can just give you like one tip that we found. We did ship our app and then looked at the crash reporting, and we noticed that, of course, there was such a crash, an invalid input index 2 or whatever. However, we noticed that it only happened on Mac Catalyst and only when it was running macOS Catalina, so the dreaded Swift UI 1. Now, there's a pattern that I've seen quite a few times is often when you have a geometry, such a geometry reader crash, it's related to geometry readers. Now, I'm not going to explain the whole concept of a geometry reader in this talk. Basically, you can get information of the layout and do like some calculations. And because our layout is is very adaptive. We actually had a situation where we used 2 geometry readers in one block of view. And we noticed that usually this is one of the cases where things go bad. You're fine if you put a geometry reader at the very first stage. But in our case, the second one, not the L matrix, but the matrix one, accessing that on the old OS caused a crash. Now, in our case, since the crash was exclusively a problem for Catalyst and there was no compact size class, you don't make the window so small that you would reach compact size class, and also not implemented that way. We simply don't call the inner matrix callback. And as long as you don't call it, SwiftUI doesn't actually try to calculate everything and crashes. So we didn't even have to rewrite the call. We just made sure that if we are on Catalyst, on SwiftUI 1, don't try to like move yourself into like a different, smaller version. Another quirk that you should be aware of is that observable object doesn't actually work for objects that inherit from NS object. Now, why would we need this? We need this base class since we still support API access from Objective-C, and the add Objective-C attribute does require NS object as a parent. Again, this is fixed in iOS 14, but if you have to support iOS 13, it's actually quite easy. You can manually define the object will change publisher, and then just simply call it yourself in will set. This matches exactly what SwiftUI would do by default and doesn't break anything on iOS 14 because you're just doing it manual where it would have happened automatically. And once we drop iOS 13, we can simply delete a few lines of code and everything will still work exactly the same way. This could also be worked by separating the class from the Objective-C compatibility layer that forwards this model. However, we chose this approach because we figured out that this is actually less boilerplate and ultimately more elegant. Now, a very common complaint in SwiftUI is that you can't do this. In the you can do this category is setting the first responder. You notice when you select type, and maybe I show it once more so you look. When you select type here, we automatically show the keyboard. So you can like start right away, and it's not like clunky Android experience where you have to tap in once more to actually get the keyboard going. And while folks are correct that you cannot do that in SwiftUI, it's also extremely easy to work around it. So my guess is also that this is something where we see an improvement in WWDC 2021, but why wait? We can access the inner UI text field that SwiftUI uses with a custom view modifier. And once we resolve this custom object, we simply call become first responder on this view, just as you do in UIKit. As an added benefit, getting access to the internally used UI text view also enables us to set a few custom properties like return key type, which is also missing from SwiftUI. Here, in this case, the text view finder is a simple UI view subclass. You notice a pattern. Again, we're using a UI view class to be embed. And this UI view subclass overrides did move to window. And in there, it looks for the UI text field that's added by SwiftUI. Now, you do need to be aware that this is undocumented. There's no guarantee that SwiftUI actually uses UI text field. Apple could just decide that they're going to rewrite controls or use something completely different that's internal only, some private UIKit thing, or doing it in completely different ways. So you need to be smart about this. In our case, we wrote this with checking the type. So the worst case that could happen is that the keyboard doesn't automatically show up anymore and the user has to have one more tab until we fix it. So everything is still usable, which means we're okay with this pattern. Even more so, actually, I would argue that the introspection pattern is something that is absolutely necessary to really polish SwiftUI. And if you see from the table here, SwiftUI uses a lot of existing UIKit components. So there's a lot of things where via introspection, you can tweak a few more things and like further increase the app polish. The popular Swift UI introspect library implements this feature and implements all of these extensions. Actually, there's a pull request open where I added a few more, which I needed for another project. But again, like I need to stress this is a hack and it's not something that's documented to work. So don't rely on this. Unlike, for example, the first responder chain trick, which is documented, and while people think it's a trick, that one fully works and has to keep working because it's documented that way. If you require access to a UI kit control, if this is like functionality that is really necessary for your app and not an extension like showing the keyboard, then what you can do is, instead of trusting Swift UI to use this component, just wrap the UI kit component yourself. This is actually quite easy. You can write a helper to do that. And in the end, you get basically the same control than using it in Swift UI because it is the same control. Now, some bugs are easier to work around than others. When testing, we noticed again with Swift UI 1, the setting a value other than 1 on minimum scale factor would simply cause an endless layout loop after deleting the last character on the text field. As a workaround, and because we wanted to make sure to like not make this mistake again, we simply wrote a custom view extension called save minimum scale factor to generalize this workaround. The experience for iOS 13 is still pretty good. This really was like a scaling issue, so like your signature can be a little larger. And eventually we can just remove this hack once Swift UI 1 is dropped. Now, you've seen that we've wrapped custom views quite a bit here already. Most of the time it is the same code, and we can write a small helper that makes this much more simpler. Remember the fine-tuned Objective-C++ based draw view? Here is how we can wrap it and configure it in 3 lines of Swift UI. In this case, actually, if we change stroke color, Swift UI will automatically rebuild the UI. So you get all the benefits of Swift UI performant view diffing, even for existing UI kit views. The wrapper is a straightforward struct. We use your view representable here. This is the standard way to do it. And we also expose an update log to make it easy to configure the view after it's been created. Now, a few last things to inspire you. We do modify the UI after drawing a signature. So that add button that you see, I can show it once more. It's only enabled once you actually draw a signature and not before, so you don't insert an empty signature. It wouldn't make any sense. What we do here is we use a combine publisher because combine just works really, really well with Swift UI. Now, the problem is that, of course, the draw view that we use is still written in Objective-C. It was written long before Apple made combine. So when we write this publisher, let me see. When we write this publisher, we don't have a simple way to just add it to the struct directly, but we can use an extension. And we can use existing mechanisms where the view notifies us of a change. In this way, a common pattern is that you use notification center. And in this case, the draw view did change point sequences. And there's another one for the draw layers. And then you can map those existing ways of notification. You can see the first one is notification center. The second one is actually KVO. And then you can map this and push this into a combined publisher. Like the view part doesn't need to care how this publisher was created. It will just work. And eventually, if you modernize the view, you can use a more efficient way of doing things. All right. We have a few more minutes. One more trick, keyboard avoidance. So this is like a topic that is like a theme and it's always fun or not. Swift UI 2 has great automatic keyboard avoidance right built in. Great. This feature doesn't exist in Swift UI 1 at all. So we had to retrofit it ourselves. In the signature view, we add a keyboard view just below the bottom toolbar. So you don't see it, it's invisible, but it's basically now hidden behind the keyboard. Initially, it has a height of 0. And once the keyboard comes up, the height of this keyboard view is modified with a calculation of the overlap that we need so that control is still fully there. Now, this all is a little tricky. But the keyboard view itself is actually quite simple. It simply wraps, again, a UI view. And we also use a coordinator, which is also something that's a pattern when you wrap views. So we add additional logic in there. And in the coordinator, I'm sorry, this is now a little bit more code. All the technology parts are in there. So coordinator is a class and not a struct. And SwiftUI will make sure to keep around the coordinator class as long as your view is displayed. We do listen to keyboard will change frame notification. And on getting it, we get the keyboard rect. We convert it to be in the hosting controller, and then we calculate the intersection height. This is gnarly because keyboards are tricky. And in this code, we also make sure that we deal with situations where the keyboard is not docked, which is a thing on the iPad which a lot of people forget. Now, also, you can't forget that the form sheet we use to present is UIKit, but the presentation logic itself has keyboard avoidance built in, but of course, only like the sheet cannot actually move content in the sheet. So what we do here is actually we wait one run loop. So we wait for UIKit to adapt the whole sheet and move it up. And then after this run loop then we do our calculations and see how much more we have to adjust to calculate to actually make sure that all our content is visible. Now, in order to get the exact same behavior on iOS 14 and keep the code simpler, we disable automatic avoidance on iOS 14. It's quite easy. There's a ignore safe area property, but again, this is only available in iOS 14. So you want to write a helper like read it here, ignore built-in keyboard avoidance that just does the right thing and basically does nothing on iOS 13. Now, we could rewrite all that once we drop iOS 13, but because this works and it works on both versions and getting the keyboard avoidance just right is often tricky, we probably just leave that in. There is no need to branch out and redo it after we drop a version. Now, fitting everything together and so you have some idea, this is how keyboard view is used. It's basically the last view in the section. You have the text field, you have the signature font list, you have the signature bottom toolbar, and then you have this keyboard view, which is initially 0. But as we listen to the keyboard, it might expand and change in height. Now to summarize, we talked about the state of SwiftUI. We talked about mixing with existing code. We talked about presenting popovers, toolbar logic, working around bugs, especially with the geometry reader, wrapping views, first responder setting, retrofitting combined. Ultimately, we consider our SwiftUI experiment a success. While we were not any faster this time around building the feature, we now have a robust set of workarounds and also the experience to deal with SwiftUI 1's issues. And ultimately, we are more confident in the correctness of our code related to state changes, because that's something that SwiftUI just gets really well. Plus, and you can't dismiss that everybody in the team was psyched and excited to learn and try and use and ship a new technology. And we'll definitely increase our use of SwiftUI in the future. All right, thank you, and I'm looking forward to QA.
Okay, thank you, Peter. Thank you very much for this good insights on SwiftUI. There is a lot of questions coming in and a lot of thank yous. So again, also speaking for the audience, thank you very much. Yeah, let's see what questions we pick. Maybe we start with Patrick, who is asking, does SwiftUI work well with per se MVVM or Viper architectures? Is it mature enough to handle, for example, caching pictures from web like Kingfisher port? So a bit specific, but yeah, try.
Yeah. So Swift UI by default already gives you a solid structure how you build things. I wouldn't say that you actually need or benefit a lot if you use MVM or Viper per se. Something that a lot of people love is the composable architecture, which uses reducers to really make it very obvious where your app state is and how you change it. And that also makes testing easier. Personally, I'm not a big fan of Viper, especially because it doesn't seem to fit so well in Swift UI. But there is nothing from stopping you if you want to use this pattern. It's quite flexible, and it's probably less code than doing the same in UIKit. In terms of showing pictures from the internet, this is apparently it's a really hard problem. There's a lot of code that doesn't quite get it right. I suggest there's an open source library called Nuke, and an extension was called Fetch Image, which uses state object. It's iOS 14 only. I think that's the best one that you can currently use. If you have to use iOS 13, there's some explanation how to do that too. But yes, at least the current version is very much capable of showing remote images.
Okay, thanks. So let's go for the next question. Do you think Swift UI will replace UIKit at some point?
Not really. It's more like it sits on top of UIKit. So it's like one abstraction level higher. You usually write Swift UI, and sometimes when there's like something that's very important or it has to be like very fast, you drop down to Swift UI. So I'll give you an example. I currently work on a different project, and I need a map with thousands of annotations and clustering. So Swift UI has support for map, but I'm like at the limitations of like this simpler API. So what I do is I drop down, I use the UIKit version, which is ultimately under the hood the same, but I have to write a little bit more code, more like twice as much code, but I have full control and can fine tune it, like can fine tune updating, which also means I can introduce more bugs, but also like it's more performant. So it's more like the majority is easier and you drop down to the platform specific levels if you need special things, more performance, more customization than the current API does.
Okay, next question, also about UIKit and Swift UI. Someone is asking for a friend starting with iOS development. Should she start with UIKit or Swift UI? Like,
start with Swift UI. It's like you certainly really benefit if you know and understand the lower levels, and in this case it's UIKit or like even further. But Swift UI gets you going so quickly, and it's like it's so much fun, especially if you forget about Swift UI 1 and just use the latest. So you make progress so quickly that should just help you in learning, because you make so fast progress, and then you can still always like dig deeper and learn more.
Okay, perfect answer, I would say. Then next question. Do you know about some complex apps in production that are written entirely using Swift UI?
I think this is changing. There is a bunch of open source apps that try it, especially on the Mac. It's a little bit of a problem. On iOS, you have some indie apps that do ship in full Swift UI. The larger companies, they have a slower cycle. They're just now dropping iOS 12, so they can now consider writing Swift UI, but have to deal with iOS 13. Not every company is willing to do that. And writing your complete app in Swift UI depends on the app, might not be possible. But I wouldn't say you don't need to be a purist. You can use Swift UI for some parts, or worst case, you just use it as the layout manager and use existing AppKit for anything else. And even if you just use Swift UI for settings, you already saved a lot of code. So no, to answer the question, I'm not aware of any big apps that made the jump yet, but I'm pretty sure it will change in a year or two.
Okay, perfect. Is Swift UI more memory expensive in comparison to UIKit?
Yeah. Apple makes this point of like it actually is, they can optimize more, so it can be more efficient. But a lot of the automatic diffing ultimately is more complicated, needs a little bit more memory. definitely needs a lot of more CPU cycles, and it's also quite easy, especially if you don't really understand what triggers updates, to write a slow Swift UI app. But honestly, in most cases, with the modern devices we have, it doesn't matter. And there's a pretty good instruments tool where you can actually identify. Like I made a mistake where I show an avatar view, and it was recreated 80,000 times. I was wondered why my app was slow, needed a lot of memory. But instruments can help you there. It has a specific SwiftUI instrument. So yeah, probably memory actually not so much. If then CPU is probably like the thing that is a little bit more of a problem.
Okay, then there is one thank you, really cool insights. So thank you. Then the next one where we can find the slides. Yeah, for everyone who doesn't know, you can basically watch this recording also on demand on WeAreDevelopers.com. So feel free to do so. You have also the stream here. And you can rewind if you jumped in at the later stage. So make use of that. And then the slides itself, we can basically share it in our wrap-up newsletter. And maybe Peter, you can also post it on your Twitter.
Yeah,
so
there will be.
Make sure to follow Peter on Twitter. That's always a good idea.
And they will be on SpeakerDeck. So if you go to SpeakerDeck/Stipete, you'll find the slides.
Perfect. Then Claude. I hope I spell it right. Claude, is asking, can you integrate SwiftUI with Combine?
Yeah, I would not even say you can. You should. And some of the things that SwiftUI uses, like at published, actually is using Combine. So if you have the standard pattern where you have a view and then a model object, and the view has a add state object and basically observes your model object, it observes as a hidden publisher that gets automatically inserted by you having a superclass of observable objects. So it is already using Combine under the hood for all the update changes. And yes, as you like, for example, this add button, like I added a Combine publisher to like change a variable. So the publisher just changed the variable, and the variable is add published, which detects changes and then changes the view. So SwiftUI and Combine is like a dream team.
Okay, good to know. Then there is another thank you and another thank you, and then there is one last question from Mr. Anonymous or Miss Anonymous. I have never used SwiftUI, so I was wondering how easy it is to write unit tests on it.
Yeah, for your model logic, it's actually not any different to Swift. So that part is the same, but it really just depends on your structure. Again, the composable architecture makes testing extremely easy and has some really good ideas on that front. If you care about UI testing, you can just use the existing XUI frameworks for simulating touches and directing everything. It's under the hood. It uses the same UI kit controls mostly. It uses the same accessibility system. So you can just say, click the second cell on my people table view controller and then check that something happened. Very much like you do currently in Swift and UIKit.
Okay, perfect. That was already the last question. So Peter, thank you so much. It was really a great session. A lot of questions, a lot of thank yous.
Thanks for having me.
That you will join us in the future again, that you will get some time.
Yeah, absolutely.
And that we also get the chance to meet in person at some point again.
I certainly hope so, yeah. Seems like there's a light at the end of the tunnel. Awesome. Okay. Thank you very much.
Yeah, then thanks. Enjoy your day. And we are going for our next session. We will do a short break, 10 minutes. Grab your coffee or tea or whatever you drink. And see you again at 4 p.m. sharp.
job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to 130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Welcome back to our last session of today's iOS Developers Day. I'm here with Sebastian. He's joining us from Paris. Sebastian, thanks for joining us. How are you?
Hello, sir. Thank you for welcoming me, and thank you for having me today. I'm really well, thank you. I'm from Belgium,
Perfect.
actually. Speak French, and I live in Paris.
Oh, that's a nice combination. Tell us what are you going to talk today about?
So for the last conference today, we are going to talk about the Swift programming language, that language developed by Apple, but how to run Swift programming language on the server side, on your backend in the cloud.
Well, that's a nice topic. So, Sebastian, looking forward to that, and the stage is yours.
Thank you. Good afternoon. Thank you for being here. It's the last session today, so I hope you have enough coffee. I will try to keep you awake for the next 45 minutes. I'm going to talk about server-side, serverless, Swift components. So that's a lot of keywords. I packed them all in one title. So let's break them first one by one. Server-side, you know that Today, most front-end application, including mobile application, are not standalone. They use some kind of backend services, maybe to identify user, to make API calls or things like that. So I'm not going to pitch you all the advantage of connected application here, but if I have to summarize, I would say that any modern app today is using at least 3 different types of backend service. Probably an identity and management service to authenticate user, probably some kind of API to REST or GraphQL API to access database and data, or other systems, and probably some kind of object storage, file storage, where you can store video or pictures, music, and stuff like that. And actually relying on the backend for functionalities allows you to be more agile because you can update the backend without to update the front-end application. Your updates are available immediately to all your users. You don't need to go through the Apple verification, certification cycle and wait for the application to be published and then downloaded by your customer. So there is a lot of advantage of moving your functionalities back to the backend. However, I remember when I created my first application, it was 12 years ago already, in 2009, having a backend was super expensive. It was time consuming. I had to rent a virtual private server from a hosting company, to install the runtime. At that time, it was Python, then the frameworks, like an application server for Python. I had to maintain that server, so to patch the server with new version of Python, new version of Linux, whatever. I had to make backups. And I'm not even talking about scalability. What if my app was becoming super successful? Hopefully it was not the case. I didn't have that problem. Or what about reliability? If the server is not available anymore, my app is not working anymore. So fast forward to year 2021 with cloud and serverless. So now you can have access to backend functionalities in the cloud, super reliable, super scalable, with zero maintenance, and that for the price of a cup of coffee per month. So what is serverless? Serverless obviously doesn't mean that there is no server. There is no magic. We need a place to run your code somewhere. Serverless, when I'm talking about serverless, I'm talking about 4 different things. The first thing is that there is no server to manage. So of course there are servers, there is no magic, but you are not responsible to manage your server. So yes, you heard me correctly. You do not need to provision, to create, to install, to patch, to backup, to ensure the high availability, the scalability, to include all the tools, the frameworks that you're using. We will do that for you. So AWS is going to do that for you. We also design serverless services to be highly available and to resist the failure of a data center. For example, your service will continue to work because we have multiple data centers per region. And the service will scale with usage. So if you have 1 request per day or 1 million requests per hour, the scalability will be automatic. It will be on our side. So you don't have to do anything. And that's great to hear as well. When you're a front-end developer or full-stack developer, you don't want to deal with scalability issue. But the best part is the last one. You pay only for the value. It means that you only pay if someone is using your service. Let's imagine that you have an API, for example. If 0 person are calling your API, you will pay 0. It's not like having a virtual private server running, because if you have a virtual private server, even if nobody is calling your API, you still need to pay for the server. With serverless, it's not the case. You truly pay per usage. So there is no upfront cost, no commitment, no fixed price per month. It all depends of usage. If your application has a lot of success, you pay a bit more. If your application has very low traffic or no success, which I don't wish you that, but you will pay close to 0 with a serverless solution. And there are tons of serverless solutions in the cloud, in the AWS cloud in particular. Think about Amazon S3. Maybe you heard about that service that allows you to upload and download files. That's serverless file storage. We also propose you serverless database, NoSQL or relational database. You have serverless environment to run your Docker container with Kubernetes, for example. But today I would like to talk about one serverless service called AWS Lambda. So Lambda, it's a fully managed service, so it means you don't have to manage it. We do it. That allows you to deploy your code. So you have code, you zip your code, you upload it to Lambda, And that's it. We take care for all the rest. There is no operating system to maintain. There is no language runtime to install. There is no backup. It has the scalability built in. You can have millions of calls per hour or 0 calls per hour. We manage the scalability. And there is only 2 price metric dimension. One of them is the number of seconds the function will run. It's a price per millisecond, actually, because we charge you by the millisecond of execution. It's 0.00000, so 16 dollars per gigabyte second. And you also pay per request, so the number of requests you receive, and the price is 20 cents US dollar cents, 0.2 US dollar per million of invocation. And the first million every month is for us, it's for free. So you can play with Lambda for free, basically. If it is just development and testing, it's very unlikely that you go over the 1 million requests per month. So what are the supported language for Lambda? It's Python, Go, Ruby, C#, Node.js, Java. You write your code in one of these languages, you package your code as a zip file or as a Docker container, and you upload that to Lambda, and then everything happens on that side. And how you trigger a Lambda function? You put something else in front of Lambda, basically. It might be an API gateway, so it's also a serverless service, serverless by the definition of serverless before, that allows HTTP GET POST call, and for each of these calls will trigger your Lambda function. So typically you're going to have one Lambda function per implementation of a REST API, but it can be a GraphQL API as well, or it can be a message arriving in a queue. Remember, application to application, asynchronous communication with queues. Every time a message is dropped in the queue, you might have a Lambda function that triggers there. We have some database, serverless database that can trigger Lambda as well when you insert, update, or delete object, or on Amazon S3 as well. For database, Lambda might be seen as the stored procedure of the 21st century because it allows you to execute code before or after a change in a database. And then you can trigger Lambda on schedule as well, like a contap, like every hour, every 15 minutes. So it's really up to you. It's the same function. It's different events that trigger the Lambda function. So before going into more details about how to get Swift running into Lambda, let's have a very short demo of AWS Lambda itself. The picture you have there is the dashboard of the AWS Lambda console. On my personal account, I have a couple of Lambda deployed, 7 as you can see. And there is a bit of monitoring that you receive, like the number of invocation, the duration of a call, the number of concurrent execution, and stuff like that. So I'm still sharing my screen, but I'm going to my Lambda console. I hope you can see it well. I make the screen a bit bigger, the font a bit bigger, so it doesn't lay out correctly on the screen. It's much nicer in reality. But if you want to create a Lambda function, you click Create Lambda Function, you type demo, you choose the runtime. It's one of the one I told you, and you see Swift is not there. That's the rest. So stay tuned for the rest. Let's choose Python here and create a function. So it should take 1 or 2 seconds. And yeah, sometimes it takes 5 seconds, sometimes it takes 10 seconds. And obviously it's when you have a demo, then it takes a bit longer. But eventually you have a very basic Lambda function, which is created for you that receives an event, a context. It returns a JSON object with status code 200 and hello from Lambda. So I can test that directly from here. If I test, I have to define the event, the parameter that I will receive. So, for example, if it is an API gateway, or if it is an API gateway, the type of event that we are going to receive is this, with the path, the header, the HTTP header, and some other meta information. So here my code is not taking care of that. So I take whatever event the Lambda function will receive. And now I can test that just by clicking test, and I see the execution result here. It's status code 200, body hello from Lambda. If I change that, hello from Python Lambda, and deploy this change and test again, you see that it's hello from Python Lambda. So you see, it really takes a few minutes to create a first Lambda function. And of course, that Lambda function is not triggered by any service. So right now, it's not super useful, but it can become triggered by a service. And that's what we are going to see in the rest of the presentation. Okay, by now, I think you get all the benefits of AWS Lambda to run your server-side code because you only pay for what you use. It has automatic scalability, automatic resilience. But what if you want to write a Lambda function in the Swift programming language? Because, hey, you're an iOS developer, tvOS, macOS, and you have your skill set, you know Swift, you have your tools already, you have your library, you know that favorite library that you are using that helps you to be more productive. And also because Swift is a great programming language. It has a strong type checking, it has excellent memory management, it has a C-level runtime performance. So what if I want to use Swift on AWS Lambda? And actually, a bit more than a year ago, AWS introduced something called AWS Lambda Custom Runtime. So that's the ability to deploy any function written in any programming language as a Lambda function. And basically, the idea of a custom runtime, it's a daemon that will work, that will run inside the Lambda micro VM, and that will poll the Lambda service to say, hey, do I have something to process? Do you have an event for me? Hey, do you have an event for me? No. Hey, do you have an event for me? No. But when there is an event, like an HTTP API call, the Lambda service will pass that event to your runtime. And then your runtime process it and then call another API to the Lambda service to say, hey, I'm done. This is the result. So all you have to remember, keep that somewhere in your mind, is that a Lambda function runs as a micro VM on Amazon Linux, which is one distribution of Linux. So the only requirement is that your binary must run on Amazon Linux. That's the only one. So the anatomy of a custom runtime, it's a binary, or it might even be a shell script. I wrote a custom runtime in shell, but made of two parts. The first part is that bootstrap. So the bootstrap is what the micro VM will execute. And basically, it's a continuous loop that pull event from the Lambda service and delegate the management of that event to some other part of the code. And whenever there is a result, a response, or an error, it just post, make an HTTPS post REST API call to AWS Lambda to post the response. So the bootstrap is fairly generic. You can reuse the same for all your Lambda function. The handler code is very specific to your Lambda function. It's how you want to handle the event that you receive. So how you package that, it's entirely up to you. It might be one single zip file, one single binary where everything is included, or it might be separate zip file or separate binaries. You might have a shared library for the bootstrap and the handler code in another binary. We don't care. As long as you give us something that is called bootstrap that interacts with the Lambda runtime, that's all what we, service provider, cares. So now you know how to write a Lambda function using the Swift programming language. All you need to do is to write a bootstrap application that will make an HTTPS call to Lambda to fetch the event, process the event, and then make another HTTPI post to the Lambda service to give the response or the error. That seems a lot of work, no? Yes, it is a lot of work to do it correctly with all the performance you expect and all the reliance that you expect. So I have a good news for you. The Swift server-side working group create that runtime for you. And Apple is working on that. It's two guys, Tom Doron and Fabian Fett. Fabian is a European guy actually from Berlin in Germany. And they create the AWS Lambda runtime for Swift. So that's part of the official GitHub Swift server project. And it's a library that contains the generic bootstrap code. It interacts with the Lambda runtime, but it also provides a popular type definition, Swift type definition for the most common event that might trigger your Lambda function. So you have API, HTTP API, S3 object, SQS message, or queue message, application load balancer. And it's written with the Swift non-blocking IO framework for HTTP as a client. So it's very, very performant. So let's have a look at how it works. If you want to use the AWS Lambda runtime for Swift, Swift, the first thing you need to do, of course, is to add the dependency to your project. So assuming you have a Swift server-side project, you have a package.swift file. Inside that file, you add the dependencies to the project and the specific version. As of today, it's 0.4. And then you add the AWS Lambda runtime as part of your dependencies. The library provides you three different protocols between the Bootstrap and your code. So you can write your code, your handler code in three different ways. So let's explore these. The highest level of abstraction, and probably the easiest one to use, is a closure. So you just call Lambda run, and you pass a closure as parameter, and that closure as a function callback as a parameter. So let's have a look at that closure. So the closure receives three parameters: context, which is the execution context of your Lambda function. This is something provided by AWS. Typically, it has the geographic location of your function, the execution time, the time of the day, tons of metadata about the runtime execution environment for your Lambda function. The request is whatever you receive from the trigger. So it might be as simple as a string, but most of the time it's a JSON document that might be short or long, depending on the service that will trigger the Lambda runtime. And the callback is a function that you need to call when you end up processing the request. So you do all your processing. You might call other API, for example, call a database, do whatever you need in your Lambda function. But at the end, you need to call callback with success or error and pass the response that Lambda needs to return to whoever calls you. Most of the time, you are not going to receive a string and response with a string. So you will have a request and a response that needs to be codable so that we can encode and decode them from a JSON document. So up to you to create the type that match that, the Swift type, and you benefit from the compiler type safety and the strict type checking that the compiler is doing for you. But this is a much more much more real life example, with a request being a JSON object and a response being a JSON object as well. Most of the time, your Lambda function will be triggered by an HTTP API, REST or GraphQL, Amazon S3, a database, a queue, things like that, or a scheduler, just like I said. So the good news is that you don't need to type and to create Swift object for all these JSON types that your Lambda function will receive. The library also includes Swift type definition for all of these, at least the most common one. So you just need to import AWS Lambda events, and then you get access to multiple types that are provided by the library. If you are writing a very performance-sensitive Lambda function, there is another way to provide a handler. So the first way was to provide a closure to lambda.run. The other way is to override or to create a structure called a handler, which inherits from event loop Lambda handler. And there, your code will run directly on the event loop, the Swift NIO event loop that the Bootstrap, the library code, is using to interact with the AWS Lambda services. So it means it's a bit more performance, because with the closure that we saw just before, every time a request arrives, the default handler creates a thread and run your closure in a separate threads. It allows a bit of safety there, because if your application does something really stupid and blocks, at least the Bootstrap still continue to work and can give a response to the Lambda service if your code does a timeout, for example. Here, you are running directly on the Swift NIO event loop. So it's your responsibility to not block that loop. Otherwise, you are going to block the entire runtime. It will not fetch future event from the Lambda services. The advantage is that you have low-level control on the loop. But with great power comes great responsibility. So beware and be careful if you are using this type of handler. Once you have your structure, you just instantiate the structure and you pass it to Lambda run as well. So there is Lambda run of a new handler. And then for some case, there is a third protocol that you can use, which is really, really low level. because in the two other protocols, you receive a Swift object as the request, and you give a Swift object as the response. Here, in this protocol, you have direct access to the byte buffer. So this handler is called even before we are trying to convert the JSON object or the whatever object we receive to a Swift object. So you can work at byte level. Imagine, I don't have a lot of use case for that, but imagine that you have a Lambda function working on image or sound, for example, and receive really really small sound clip or image as bytes. That would allow to manage the bytes directly there. Once again, you're running directly on the Swift NIO event loop, so be careful to not block the loop if you are using this one. Yeah, most of the time you're not going to use this one. Okay, now you know how to write your code. You have the bootstrap provided by the library. You have the common AWS types definition that are provided by the library. All you need to do is to write an handler. How are you going to build that? Swift build, yes? No, because if you type Swift build on your Mac, you're going to produce a macOS binary. And remember, AWS Lambda does not run on macOS, it runs on Amazon Linux. So you need to produce an Amazon Linux binary. So our friend here will be Docker. You just need to create a Docker container with Amazon Linux and with the Swift runtime and the Swift compiler. You start that Docker by mounting your directory, your project directory with your files there, so it can read the files there. You do not need to copy the files inside the container. You also, this is also where the compiler will produce the binaries on your file system. So you do not need to export the binaries out of Docker at the end of the compilation. You just mount your directory. And after that, once you're inside the Docker container with the correct directories mounted, it's as simple as typing Swift build -c debug or -c release. And okay, you're going to tell me, but I don't want to create a Docker container with Swift. And you don't need to, actually, because Apple is also providing an Amazon Linux and many other distributions as well, container with the Swift programming language. So all you need to do is to have a small Docker file saying from Swift 5.4 Amazon Linux. I put 5.4 here on the slide because I want my slides to be future-proof. As the moment of I'm speaking right now, April 28, it's roughly 4:30 CEST, the 5.4 is not released yet, so you need to use 5.3.3, or you can use a nightly build for 5.4. As you know, 5.4 has been released just 2 days ago, and I'm pretty sure the Docker container would be available any minute now, probably over the weekend. Now you have your binary. Excuse me. Now you have your binary. How are you going to package that? Remember, to upload a binary to Lambda, you need a zip file. So how do you create the zip file? Because in the micro VM that Lambda is running, there is no Swift runtime. So if you give a Swift library, a Swift binary there is no all the shared libraries that allows to actually run that binary. So you need to ship that inside your zip file. So your zip file will typically contain your binary and all the libraries that you need, that your binary needs to actually execute your application. How to get the list of binary? The easiest is to use the LDD tool on Linux. So you start your container again and you type LDD with the name of the executable. It will give you the list of all shared library used by that executable. And then you see there on the left side of the slide, you just grep to keep only the Swift, the names with the Swift inside. You take the third column and then you package that as a list of arguments for a copy command. So you're going to copy all these files to a target directory. And target directory is your working directory. Once you have your binary and all the share library there, you zip that, and that will be the file that you can actually upload to Lambda. Great. So I just need to add AWS Lambda runtime as a dependency. I run my handler. I use a Docker container to do the compilation and the same Docker container to do the zip. So how to get started? Because it looks like it's a lot of files and to create just a very simple project. So I have another good news for you. One of my colleagues, you might know him, it's Kyle Lee on YouTube. His name is Kiki Loco. He's doing a lot of Swift programming tutorials on YouTube, he created a very short command line utility that allows you to scaffold to initialize a new project, so create all the default files and default directories. And I modified this project to also include the possibility to deploy your command or your Lambda functions directly from there. So that utility is called Slam for Swift Lambda Maker. You can find it on my GitHub account. Let's see how it works. So I'm going to switch to the terminal, and I'm going to create a hello world directory. Of course, because I'm doing this demo quite a lot, it exists already. So now I have my hello world directory. Using Slam, I can just type slam new, and it will scaffold my project directory. So it will create a project, all the required file, create an Amazon S3 bucket to upload my Lambda zip, and prepare a Docker image for me that I can use a bit later. Usually preparing the Docker image should be super quick. Once again, it's the demo effect. The time of the demo, it takes longer. Let's see. So slam new, just create that. Maybe while he's preparing the Docker image, I can already open Xcode and to see what are the files that are that have been created for me. So I have a Xcode project here, and you see there is a package.swift file that has the dependencies over Lambda, that has the dependencies for the Lambda runtime and Lambda event. It also have the very simple Docker file I was talking about. Remember, I'm using the nightly 5.4 right now. It will be replaced by 5.4 final when it will be final. It has a sample event, so a sample JSON file as if your Lambda function was called from the HTTP API gateway. And it has the Lambda function itself with Lambda runtime, Lambda events. It assumes that this function will be called by an HTTP API, so it has the type for request and response, and it used the closure Lambda run with the context with an HTTP API request and the callback. So here I can put my code, and at the end I just call callback success and pass an HTTP API response, which has a status code depending on what you want to return through the API, but let's assume it's HTTP 200, okay, and a body here, it's just hello world. So that's the code that has been scaffolded from me, for me, by the Slam tool. And I don't know what the Slam tool is doing, but it's still preparing the Docker image. So next step would be, once you are ready, to type slam build, and it will actually run the container for you. Okay, I can do it now. Slam build, it will start the Docker container for me and run the compilation of my package inside that Docker container. But you see the advantage of that little Slam tool is that it hides all the complexity of having Docker, typing the full Docker command, mounting the directory correctly, and so on and so on. So Slam build, and then Slam package. The very first time you're doing a Slam build, it might take a few minutes because it needs to download the Swift AWS Lambda runtime and to compile it and all the dependencies as well. So it might take a few minutes. This is totally accepted or expected. I was planning to show you how to invoke that, but given the time it takes to build the Docker image and to actually build the package, I think I will go back to the slide and let that for a bit later. But the good news, you can zip also, and you can make a local invocation of that code. So you can test that code locally on your Mac, maybe in Xcode by putting a breakpoint, for example, in your project and doing local debug even before to deploy that. The Lambda runtime, the Swift Lambda runtime provides a mini web server that you can use to actually test that code locally. But okay, I don't know why it's taking so much time today. So let's go back to this and explain a bit about the deployment of the function, because if you do the build and the package, you have a zip file, great. And then what do you do with that zip file? You need to upload it to Lambda. So the first method to upload it to Lambda is maybe just to take the console, just like I did in the first demo, and go in the console, create the Lambda function, upload the zip, and click, click, click. But doing deployment of backend service through the console is not the best practice, because it's very difficult to repeat. What if you need to deploy 30 functions, maybe in 3 different regions, and then you multiply by 3 environments, you have dev, test, prod. How are you going to ensure that your deployment is repeatable? It's exactly the same. How are you going to ensure that you are not making any errors? So the best practice is to script that. And the first, maybe naive way to script would be to use the AWS command line. So AWS command line is something you can install on your Mac, brew, install AWS CLI, and you're good to go. Of course, you need to have credentials. You need to have an access key, secret key to authenticate you towards AWS. But once you have that, AWS Lambda create function. And then it has 5 parameters: the name of the function, the zip file, the permission. I'm not going to talk about permission because it's not an AWS tool right now. It's on Lambda just. The runtime, and here the runtime, it's not Java or Python. No, it's a provided Amazon Linux 2 runtime, and the handler is the entry point in your code. And if you write Python or JavaScript, you have to give the name of the file and the name of the function to call. But here it's provided, it's your bootstrap provided by the AWS Lambda runtime. So that simple command creates a function. After that, if you just want to update the code, you can call AWS Lambda update function code with the name of the function to update and just the link to the binary file. So that's much more repeatable, because if you need to repeat that in multiple regions, you can just change or add a region parameter there. That's better. But what if you have dependencies? Like in my example, I want also to have an HTTPI gateway in front of that. And imagine that my code needs to access Amazon S3. Then I will need to give my code permission to access Amazon S3 on my behalf. So that's a lot of these commands to type, and maybe you don't want to do that. So to help you to manage the dependencies and to easily deploy your Lambda function, I'd like to introduce another tool. It's the 3rd or 4th one in this talk. It's called SAM. And SAM is the serverless application model. So with SAM, you can describe your application in a text file, and then SAM will create all that infrastructure for you. So in a text file, you say, hey, I have a Lambda function, I have an HTTPI gateway. My HTTPI gateway will call my Lambda function, and my Lambda function needs Amazon S3 permission. And you describe that in a text template, in a YAML template. So that code can be part of your source code control. It can be versioned with your project. And that's the definition of your infrastructure that you can then deploy in multiple regions or in multiple environments. You execute one time the file against dev, another against test, another against prod. And that's the way you can manage multiple environments in multiple regions. This is what we call infrastructure as code, IAC. So let's zoom there on the relevant part. You see at the bottom, at the top, sorry, 4th line, there is resource. That's all the resource you're going to create. And then you give a name. I choose API gateway function. It's not a great name, but you see the type. The type tells, hey, this is a Lambda function. This is a serverless function. And then you see the parameter, handler, runtime, code URI. And it's the same as in my command line. Yeah, because at the end, I'm just calling the same API to create that. But there are a couple of things more, like policies. That's a predefined policies provided by Amazon to give read-only access to Amazon S3. And in events, you see that I want one of the events for that Lambda function, I want it to be an HTTP API. And the API ID is a reference to another resource that you will see in a second. And it will be triggered when we call /app with a method get. It might be post, might be delete. If you know REST API, you have all the flexibility that you need there. And a bit below there, you can see the Lambda API gateway, which is my HTTP API. It's another resource. And in the output, you have the URL of the API gateway. So it will give you directly the output of the URL address, sorry, of the API gateway. So if you want to deploy that with Slam, you just type Slam deploy, and Slam will, sorry for the name, Slam will call Sam to deploy this resource and create this resource for you in the cloud. It takes a few minutes. And after that, it gives you the URL of your API gateway. So here, it's an opinionated tool that configure Lambda to be triggered by an API gateway. But of course, you can change that and adapt to whatever you need. So let's see if I can make a demo of that. Here I have that's my hello world that eventually finished to compile. So let's finish that. Once I have something that compile, I can just type Slam package to create the zip file. And then I can type Slam deploy, and it will deploy my function to the cloud. But before that, I told you I can type Slam invoke. So the invoke is not fully automatic. I was a bit lazy right now. I'm just giving the instruction that you can use to actually invoke the Lambda function, and that should return immediately. I don't have what I don't know what's running on my machine right now, but it's really not the good moment to do a demo. Anyway, come on. Oops. If you want to invoke, you can position an environment variable called local lambda server enable equal true, and then call your binary. Of course, it has to be compiled for Mac if you want to do that. So compilation should be quick. And once I have a local build on my machine, I can just call the hello world. And you see that it is listening there. So to call my Lambda function, I can just make a curl posting the event that I show you to localhost 70 invoke. And that will invoke my binary, and you see status 200 body hello world. So that's how I can test my Lambda function locally. Here I have another Lambda function already created. So this one can be deployed to the cloud with SAM deploy. And so SAM deploy is really reading that YAML file that describes the infrastructure, executing, quote, quote, executing that environment to the cloud. So it's creating the Lambda function. It's creating an HTTP gateway. It hooks it up, the two together. So it linked the HTTP API gateway to the Lambda function. And it gives me the URL of the API gateway. So here I can just call my API gateway. I don't need to pass an event anymore because I'm not calling the Lambda function here. I'm calling the API gateway. The API gateway will generate the event, the big JSON that you saw, and call your Lambda function. And the Lambda function return HTTP 200 with hello world. The proof that it's a 200, if we put -v here, we see that we receive HTTP 200 there. So my Lambda function is deployed to the cloud, and it's available as a REST API. Okay, let's finish with something a bit more advanced, because now you have a Lambda function that says, hello world, great. But in real life, your Lambda function will probably call other AWS service or other API or database and stuff like that. So if you want to call another AWS service, such as DynamoDB or NoSQL database, for example, or S3 to manage files, you need to make HTTPI a REST call to the AWS API. And the AWS API requires authentication with an access key, secret key, and signature on URL. So it's quite a lot of code to actually interact at HTTP level with the AWS API. And that's why AWS is providing for many different languages a higher level SDK, a library that allows higher level constructs to write less lines of code and focus more on your application code. But there is no AWS SDK for Swift. So the community creates one. And that's the Soto project. So I would like to introduce you the Soto project available on GitHub at this address or the QR code there. So Soto project, it's a community-driven Swift software development kit for AWS. Most of it is generated automatically based on the API definition that we do provide. That's how we generate our SDKs as well. So they are using the same principle, and a couple of classes are handcrafted. They are manually coded to provide you higher level access. One of them, for example, is the credential provider. It's a class which is able to locate your AWS secret key and access key. So if your code is running on a virtual machine in the cloud, or in a container in the cloud, or on your laptop, or even in a Lambda function, it will try different ways to acquire the credentials. And so you don't need to take care of that. You can even forget that there is a credentials. It's also based on a Swift non-blocking IO framework for super performant access to HTTP. It works on Linux, on macOS, and iOS. And currently the maintainer is Adam Fowler from United Kingdom, and a big kudo to Adam for the work he's doing for the community there. So how does it work? Let's imagine that I want to change my Lambda function to make a call to S3, read all my buckets, all my directories on S3, and return that in a JSON document. So the first thing I'm doing, I'm creating a Swift type to define my return, my bucket list. So it's just a very simple structure, which is uncodable. I have an array of string, which is bucket, and I have a method as JSON string that produces the JSON string. Then I need to create an S3 client, an HTTP client as well, an S3 client. And once I have the S3 client, there is a one-for-one mapping with the S3 API. So list bucket. It's a method that will list all my buckets. In Soto, all methods are asynchronous. So that method returns immediately, and the closure exits immediately. So it's important to call the callback only when you will get the response from list bucket. And the first thing I'm doing when I get the response is transforming the output of the API, which is a list bucket output object, to my bucket list I just showed you before. And in every case, I'm calling the callback to tell the Lambda runtime that I'm done. It can answer no to the Lambda service. You will notice that for both failure and success, I'm reporting a callback success, because I'm telling the Lambda runtime that the execution part of my code succeeds, even if at the business logic there is an error. So the error, I report it into the JSON I'm giving back to the HTTP API. So if there is an error, I want the HTTP API to report a 500 error. So I pass an HTTP API response with internal server error status code. If there is a success, as I pass a status code OK, and the JSON string. So let's see how it works in real life. I have a project somewhere here, which contains all this code already, and there should be no surprise. It's exactly the code I show you on the slide. So I can run this locally again with the environment variable we talk about, or I can also use Slam to deploy, to package, and to test that. I will not type Slam deploy because it will take a few minutes, and we are already out of time. So let's just take a curl to the API gateway that has been deployed. The first time it takes a few milliseconds to wake up the container and to initialize Lambda, but you see that the result here is the list of my bucket. The subsequent invocations are much faster. We can even pipe to JQ to have a nice, pretty list of all my buckets. So that's a Lambda function that I'm invoking through an HTTP API, HTTPS API, that invokes another AWS services. So that was a lot. What time is it? 1 minute over. So let's just recap. What did you learn the last 45 minutes? First, I explain what is serverless. Serverless means you don't need to manage your code. Serverless means you only pay for what you use. Then I shift to a serverless compute service that allows you to deploy your code in the cloud, which is AWS Lambda. You only pay per milliseconds of execution and per invocation with 0.2 US dollar cents per millions of invocation. And the first million every month is for free. Then I show you how you can run Swift code inside Lambda using the library provided by the Swift server-side project, the Swift runtime for AWS Lambda. Then I show you how you can deploy that code very easily using SAM, including some dependencies such as an HTTP API gateway, for example. And then finally, I briefly talk about the Soto project, which is a community-based Swift SDK for AWS that allows you to actually call other AWS services from your code. And I guess with that, you have all the pieces you need to start today. The code I show you in the example, the full code, the one at the end with the call to S3, is available on my GitHub. So you can go to github.com/sepsto and get that code. Feel free to comment, to give pull request or to file an issue. Just a very quick shameless plug and auto promo. If you are interested by this type of topic, there is the MEA online summit organized by AWS coming in June. It's June 9, and I will have another talk to show you how you can create continuous integration and continuous deployment pipeline in the cloud using Mac Mini running in the cloud, what we call Amazon EC2 Mac instances for your iOS and tvOS project. So you can register there. It's for free. So tell me what you are going to build serverless server-side with Swift. You can tell me that on Sepsto on Twitter. Sorry, Sepsto on Twitter. And if you go to that URL, evenbox dev/survey and enter that code, or you scan the QR code there, you just give a quick feedback about this talk, and you can get a $25 service credit on AWS that you can redeem on your account. So you can try all that and many more, create a database, use S3 without having to pay anything, because you will get that $25 service credit. Voila, that's it for me. Sorry, I've been 4 minutes too long, but I'm staying available to take any questions.
Okay, Sebastian, thank you so much. So no problem with the 4 minutes. We have enough time also to go over the questions. So I would say we just jump right in. There is one question from Kern. How is Swift performance on Lambda? Can you say something about that?
Yeah, the Swift server-side project made some benchmark, and I don't have the numbers in mind, but Lambdas are running on micro VM on Amazon Linux, so it's roughly equivalent to the micro VM. The Linux performance you can get from a server. When you deploy your function on Lambda, you can, I didn't show you that, but you can choose the size of the container. Basically, you just choose the memory, saying how much memory you want, but the more memory you have, the more CPU you receive as well. And the price of execution is not the same, of course. So if you have performance-related Lambda function, you can choose to have bigger containers. And by bigger, I mean with more memory and more CPU that will give you better performance as well.
Okay, may I ask you to stop sharing the screen so we can get you on our live screen again? Perfectly, thank you.
Yep.
So then the next question, I think you already answered this with Soto. Is it possible to connect with SNS or SQS?
Yes, with Soto, indeed. So in Soto, you will find an SNS class, a SQS class. On GitHub, there is another project that write and read or produce and consume SQS message. So you can find code already to see how to interact with this service on my GitHub. Soto did a wonderful job. They cover most of our services because, as I said, they generate the API the SDK dynamically based on the API definition. So they are really quick to update the SDK with whatever change we produce, and we produce a lot of changes. So I think most of the services are covered.
Okay, thanks. Then the next question, is static linking possible?
Yes, of course. So you give a binary, and the Lambda micro VM will execute that binary. The only thing Lambda search is for binary called bootstrap, so you don't have the possibility to choose the name. I choose to put the dynamic libraries. You can have a statically executed binary. There might be an impact in performance for cold start. So the first time the micro VM is booting, it needs to call the binary and all the libraries. So maybe if you statically link them, it might load a bit faster. To be tested. If your application is very sensitive to that, what we call cold start on AWS Lambda, that's the very initial call on a micro VM. And you might have many micro VM depending on how many concurrent requests you receive. So if your code is very sensitive to that, maybe you can try a static link instead of using the dynamic libraries there. Yeah.
Okay, then there is another comment. Really nice. I like the idea of full stack Swift development. In my company, we use Terraform. Do you suggest some resource to understand how to deploy on it?
Yeah, Terraform is a very popular tool made by a company called HashiCorp that allows to do infrastructure as code as well. So remember what I said with SAM, where you have a text description of your infrastructure and something that execute or create an infrastructure based on that text description. So Terraform is doing that. So Terraform here it's like a competition of SAM from AWS. Honestly, I don't know Terraform, so I don't know how to create a Lambda function with Terraform, but I'm sure that what I did here with SAM, you can do the same with Terraform and probably many more as well. So Terraform is a perfectly valid option to deploy infrastructure in the cloud, in all the clouds, not only AWS. And I don't know Terraform, so I don't know exactly how to hook a Swift Lambda zip file to Terraform, but I'm sure it's easy to do.
Okay, that was already the last question. So Sebastian, thank you so much for joining us. Hope to see you in the future again, and have a nice day.
Thank you, bye.
Thanks, bye-bye. So that was our last session of the iOS Developer Day. I hope you have enjoyed it. And before we basically close the stream, I want to remind you of two things. First of all, as I said in the introduction, our flagship event of WeAreDevelopers is coming back to you. The WeAreDevelopers World Congress. We will have great speakers such as Sir Tim Berners-Lee, John Romero, Jeff Atwood, Brenda Romero, San Yusuf, many others, more than 100 speakers. You can get a discounted early bird ticket by using the code that you see on the screen. So make sure to make use of it and join our World Congress happening end of June, beginning July. Yeah, with that said, I also want to say a thank you to Rihanna Up, which is a partner of us and which is currently hosting Europe's largest startup festival. So you can also visit their website and see if there are some other events that might be interesting for you. So that's it for today from WeAreDevelopers. We will basically also see each other maybe in 2 weeks or in 4 weeks. As you know, every second Wednesday we have our live sessions. The next session is on May 12th. It's about DevOps. So if you're interested in some cool and nice DevOps topics, please just join us.
Dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to 130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.